live stuff
Okay.
earlier this year. So
Well, I will be nowhere near Good morning, everybody in Montana. Thanks for joining us today in our Montana State University Montana Agricultural Experiment Station virtual field day question and answer session. We have over 56 videos published on our field day website, can be found in the news releases and everywhere else. First of all, I'd like to thank Mike Suarez, Sharon Henderson, and Reagan Collier. They really hauled most of the water on putting this all together. And I want to thank all the researchers and people that put the videos together for the producers of Montana. There is some absolutely outstanding videos out there and learning opportunities for the producers of Montana. Pretty exciting for something that was pulled together on a COVID-19 result. We sure wish we were with you personally. We really enjoy field day. At least one of my favorite days of the year is every time I get out with the producers and sit in a wagon and listen to all the researchers throughout the real research centers and other parts of the state, like Bart Farm and Bozeman. First thing this morning, we started out with a soils and soil microbiology and pathology group. So I'd like to introduce you to our three panelists today, Dr. Clayne Jones, Dr. Jed Eberly, and Dr. Frankie Crutcher. At this time, I'm going to give them a couple minutes just to kind of introduce who they are and some real fun facts, and then we'll start right into our questions. Thanks for joining us today, and let's start with Frankie, Eastern Montana.
Yes, so I have been the plant pathologist at Eastern Ag Research Center since 2016. My job here is to come up with strategies to control diseases of important crops here in Eastern Montana. So this pretty much includes sugar beets, pulse crops, and cereals. In my program, we try to really have a well-rounded research approach that includes understanding plant pathogen populations, determining fungicide efficacy, improving pathogen detection, exploring the effect of different agronomic practices, and then really helping the breeders develop resistant varieties. So I try to know a little bit about a lot of different diseases, but I've really had to focus. And so I work mostly with Rhizoctonia root rot, Fusarium yellows, and Cercospora on sugar beets, root rot pulse crops, Ascochyta on chickpea, and then Fusarium head blight has been something I've really focused on. But if you have questions on other crop diseases, that's okay. Please ask them anyways. And if I can't answer, I'll be happy to either recommend someone who might or find that answer out for you.
Wonderful. Thank you, Frankie.
Thanks, Darren.
Let's go to Clayne in Bozeman.
Hi, everyone. I'm MSU's Extension Soil Fertility Specialist. That means I can answer any questions related to fertilizer, nutrient management, keeping nutrients out of our water. My recent research is focused on nitrogen fixation of both peas and lentils, and the video that's shown online talks about an N fixation study I'm doing in collaboration with Peggy Lamb at Northern Ag Research Center, Kevin McPhee, and Perry Miller and Scott Powell down here in Bozeman. Other research that I've been focusing on lately include nitrate leaching in central Montana, as well as the effects of cover crops on nutrient cycling. If you have any questions on any of those or anything related to soil fertility, make sure to give me a call. I also have one other video on the virtual field day webpage, and that's on the growing problem of soil acidification in Montana. So take a look at that if you're interested as well. And I hope to receive some good questions soon.
Outstanding, Clayne. Thank you. Jed, how are things in Moccasin?
Right here, Darren, thanks. My work here at the Central Ag Research Center is focused on soil microbiology, and the role of microorganisms in soil health and crop productivity is really a topic that has been of growing interest and concern in the agricultural community in recent years. You know, people often think of microorganisms as pests that are destructive to their crops and animals as well as to themselves, but many microbes are beneficial. And my work is really focused on trying to understand these beneficial interactions between plants and crops. So microbes are involved in a variety of very important functions, including decomposing plant residues in the soil through the process of mineralization to make nutrients available in this organic matter to subsequent crops. Microorganisms also fix atmospheric nitrogen for legumes. This is probably one of the best examples of beneficial microorganisms in the soil, but there's many other examples as well. One good example of this is the mycorrhizal fungi that can form symbiotic relationships with plant roots and essentially act as an extension of the roots to enable plants to access nutrients that would otherwise be inaccessible. And soil microorganisms play many essential roles in protecting plants from a variety of stressors. This could include things like drought and heat stress, heavy metal toxicity, also protection against pathogens like Frankie was talking about. It turns out that in addition to some microbes being pathogens, there's others that can provide protection against those pathogens. So here at the MSU Central Ag Research Center, my research team is working to better understand some of the key roles that microbes play in enhancing crop health and productivity. So we're working to identify beneficial microorganisms that are locally adapted to our conditions here in Montana. And within this area, we are specifically looking at identifying native nitrogen fixing organisms. And we're looking for organisms that are very efficient at fixing nitrogen, but also robust enough to survive our harsh climate conditions where they're exposed to extreme heat and cold as well as drought conditions. And we're also working at isolating and characterizing novel phosphate solubilizing microorganisms that may be effective at making phosphorus more plant available. So with that, I'll turn it back to you, Darren. Thanks.
Thanks, Jed. Looking right out of the boat, kind of a common question we see a lot of ways is, Frankie, what are we seeing for pathology problems in the state of Montana this year? What should producers be scouting for? And how does the sugar beet crop look in eastern Montana?
All right. Well, I think early in the season, what we saw most was frost damage. We had a lot of episodes of real cold temperatures, especially over here. So I did get questions about that as far as how is this the plant disease or is this something else? Weed streak mosaic virus was an issue this year because last year we had all that rainfall. We had a lot of lodging, especially here in eastern Montana. And so a lot of farmers weren't able to get out and spray and eliminate that green bridge before the fall season. So we did see quite a bit of that as well. Surprise that I saw was powdery mildew on peas. I haven't seen it this severe before, but we're very lucky in that it's occurred near harvest. So if you have seen it in your fields and it's starting to dry down already, you don't need to spray. There's not much you can do about it at this point, and it should have a minimal impact on your yield. And then lastly, what we've seen for sugar beets, we just scouted out Cercospora here on the farm 2 days ago. And so this is about 2 to 3 weeks earlier than we normally see it. And we've got some more humid conditions coming in where you're going to get that water building up on your leaf surface in the morning, which is ideal for Cercospora. So if you're growing sugar beets here in eastern Montana, it's time to go out and start scouting and looking for it. Thank you, Darren.
Thanks, Frankie. So Jed, a question coming in is how do you determine beneficial microbes from just surplus microbes, or how do you relate that back to agricultural production? Kind of a different type of question of more about the philosophy of how you go about that and why there's beneficials or what that constitutes.
Yeah, so, one of the challenges, well, I guess back up, we've known there's beneficial microbes. That's been common knowledge for many years, especially within the research community. But really the challenge has been trying to identify them and determine how many we have present in the soil and what functions are they performing there. So that's been challenging. In recent years, there have been a number of measures of soil health that have included aspects of analyzing the microbial community. So a few that have become, or probably the best known, are the Haney test and also the Cornell Comprehensive Assessment of Soil Health, or CASH. So these tests measure soil respiration, and they can provide an indication of things like microbial biomass in the soil and also the potential activity of those organisms in the soil. So some of them can also incorporate measures of potentially mineralizable nitrogen, which again, that's another way of getting some insight into microbial activity. And then there's also more direct measures of root pathogens that can be performed, and that's looking more at the part of the community that would be detrimental to the crop. So the downside to some of these approaches, though, is that they really don't enable us to directly quantify the beneficial microbes in the soil. So this is still a big challenge for those who are wanting to take a more holistic management practice that incorporates an understanding of the microbes and using agricultural practices that are of benefit to the microbes to help enhance their activity and performance in the soil. There are numerous new technologies that are under development. A lot of these are sequencing based, and while in the past they've really been too expensive for application by growers, they've been pretty much restricted to researchers. In recent years, as the technologies continue to develop, costs continue to decrease, there are some labs starting to offer this as a service to growers if they want to get a more comprehensive understanding of the beneficial microbes in their soils. And there are, some of the more traditional methods of doing direct microscopy to try to identify organisms, but again, some of those approaches are more expensive and time consuming. But I really think we're on the verge here of seeing some rapid developments as economies of scale kick in and these tests become more routine. They'll be applied at a much broader scale for growers to gain some of that information. So back to you, Darren.
Thanks, Jed. Hey, Clayton, it kind of came in from your perspective as a soil fertility specialist. How does that interact your position and what you do for producers and Jed's work with the microbiology or microbiome? How does that interact with how you two see that?
Yeah, that's a good question. I think, Jed is getting a lot more into the soil biology. I would say that I address more the soil chemistry, realizing that the two are not separable. So I understand that what drives nutrient availability, so available nitrate, phosphorus, potassium, for example, is largely microbially driven. So I have to understand a little bit of what Jed does, and Jed certainly understands my side of the business. I say I would probably use more traditional tests, laboratory tests that we've calibrated over decades in Montana to reflect nutrient availability, but we recognize that those are done in the lab and don't always reflect nutrient availability in the field. And that's what some of these newer tests and what I think Jed's trying to get after.
Outstanding. And Darren, if I could follow up on that.
Please.
As Clayton mentioned, it's this intersection between the chemistry and the biology and also the physical properties to some extent play in there. So really from a research perspective, what we're looking for is what are the best metrics that are easy to measure and economical that we can use to give us an understanding. So that could potentially include chemistry measurements that provide insight into what's happening in the microbiology, or it could be some microbe-focused measurement that would provide us some insight to what's going on in the chemistry. So these very much play an interactive role together.
Perfect. Thanks, guys. Clayton, not surprisingly, from the Triangle area, top 5 things we're working on, and how does acidic soils impact? We know it's a big problem in the Triangle right now, and you're working on that. So could you address some of the acidic soils and maybe a 5 or so recommendations, or what you're thinking for recommendations on acidic soils?
Sure. So a little background in case you haven't heard much about this growing issue. In about 2015, we discovered some acidic soils on the Highwood Bench in Choteau County, which was a surprise to me and other soil scientists because Montana's generally had alkaline or high pH soils. Once we discovered it and started looking for it, and crop advisors, producers, extension agents started looking for it, we have now found this problem of acidic soils, meaning low pH soils, in 24 of our 56 counties. Choteau County is still the epicenter, but we're finding it in additional fields. Things to look for are stunted growth, yellow to pink to purple, lower leaves. We also are seeing more herbicide carryover. So if you're suddenly starting to see more residual herbicides in pockets on your field, that can indicate low pH. Poor nitrogen fixation or nodulation of legumes is another good indicator. In fact, we call it an early indicator because the rhizobia that make the nodules and fix the nitrogen on plant roots actually start showing problems around pH 5.8 or so, where we don't see real detriment to crops till about pH 5. So it's kind of an early warning system. I like to think about mitigation, adaptation, and prevention. So mitigation would be primarily lime, often applied at high rates, 1 to maybe 3 tons per acre. Adaptation would be selecting crops and varieties that are more resistant or tolerant to low pH. Winter wheat seems pretty tolerant. On the other end of the spectrum, safflower and the legumes and durum wheat are very intolerant. And then also phosphorus can be applied with seed to tie up aluminum, which is the problem caused by low pH. And then as far as prevention, anything you can do to reduce nitrogen rates. So that would include things like using more legumes in rotation, planting crops that need less nitrogen, such as perennials and barley, and making sure that you soil test for nitrogen so that you don't over apply nitrogen. So in a nutshell, those are some of the things you should be looking for and some of the management practices you can do to prevent or correct this problem.
Thank you, Clayne.
Clayne, a follow-up question on that. You mentioned phosphorus. Have you looked at all at the economics of that? I mean, understanding that that's probably more of a temporary solution, but compared to liming, how does the economics of that play out?
Yeah, so in a study done by my colleague, Rick Engel, he found on one site in the Golden Triangle that phosphorus doubled durum yield from about 22 bushels per acre to about 43 bushels per acre. We were applying 60 pounds of P2O5 per acre, which is a pretty high rate, but you do the math, that would easily pay for itself. But in the long term, phosphorus is not fixing the problem. It's kind of helping in that particular year. And so my back of the envelope calculations show that in the long term, lime is a much less expensive option and truly fixes the problem for an extended period of time, meaning 1 to 2 decades.
Thanks, Jed. Good question. Thanks, Clayne. Frankie, I think people are picking up on a theme this morning, but could you talk to me on how these soil-borne diseases may creep up on people or kind of build on themselves?
Yeah, and that's definitely something we're seeing, especially with pulse crops. When in the scheme of things, pulse crops are still relatively new to our cropping systems here in Montana. There's 2 really big reasons why we're starting to see these proliferate now. One of them is because just presence of the host, and especially since a lot of these pulse crops especially are being grown in really tight rotations. So the more years that you have the host plant, the more that the pathogen is able to proliferate, make spores that can stay in the soil for a long time. So a really good example of this is Aphanomyces on pea and lentil. This is something that's becoming an increasing problem, especially here in eastern Montana. It's very host specific. It makes spores that can stay in the soil for 10 to 20 years. And it takes time for it to build up. And so what we've seen and what producers have noted is that it takes 5 to 6 growing seasons with pea and lentil for you to start seeing symptoms. So this is why it's really important to diversify rotations, to lengthen the time that peas or lentils are in your field when it comes to Aphanomyces or other root rot pathogens that we're seeing. It's also important to know what you're working with. If you see that plant that's not looking so good in your field, it's good to pull it up and look at the roots. A lot of times people forget that these diseases can be on the roots. And, send it into the Scudder lab. They have a quick turnaround time, and they can give you some really good information so you can start making decisions on if you want to change up your agronomic practices or your rotation schemes, if you want to add a more specific seed treatment, or if you maybe want to choose a resistant variety, try something a little bit different. And so knowing what you're dealing with gives you more choices. So.
Good.
The second reason actually has to do with Jed. Having diverse microbial life in the soil limits pathogen activity. And so knowing more about that is obviously very important for controlling plant pathogens.
Right. So really quickly, Frankie and Clayne, you both talked a little bit about the past two topics about variety or resistant varieties. And I know we're going to have our breeders on today, but in both of your cases, maybe acidic soils and in some of the disease prevention, how do you guys interact with these, and what do you see on the forefront in the breeding programs?
Why don't you go first, Frankie?
Okay. I'm really blessed to be working with a group of breeders who take plant diseases very seriously and are very active in breeding for those. So for our cereal breeders, they're all very focused on Fusarium head blight and have put a lot of effort into starting to breed for this resistance and get out some good regionally adapted varieties for us. I have a nursery here in Sydney, and we have one for winter wheat down in Huntley where we're screening these different progeny and varieties that are recently are going to be or have been released so that you can get really good up-to-date information on that resistance. For the Pulse program, Kevin McPhee has focused on a variety of diseases. Him and I have started a project to start breeding for better resistance to Ascochyta for chickpea, which really plagues producers who want to grow chickpeas. It definitely has to be one of the big determining factors on whether or not they're going to grow it. Because once you've had a couple seasons of it, it really starts to become a problem. If the weather's right, you could be spraying 4 or 5 times. So adding a resistant variety would be beneficial.
On the acid side of things, all 5 of the breeders, so Jamie, Phil, Luther / Jason, Kevin, and Mike Drew have all been working on tolerance to low pH in acid soils, which is pretty impressive because it's still in some ways a relatively small problem in Montana. It's a big problem for certain producers though. Rick Engel, Pat Carr, Simon Fordyce have all been working up on the Highwood bench, sometimes in collaboration with these breeders, looking for varieties that are more tolerant to low pH and what the end result of low pH is, which is high aluminum in the soil. The research is extremely challenging because none of these sites are uniformly low pH. So we end up with high variable results. And like with any breeding program, it's going to take time to develop varieties. Fortunately, some of our colleagues over at Washington State have developed some spring wheat varieties that are tolerant, and those are actually right now being grown in Montana. We also have discovered varieties that appear to have aluminum tolerance, even though it wasn't bred for aluminum tolerance within Montana. You can find a list of those varieties on my webpage. And if you want to find my webpage, just Google Clayne, C-L-A-I-N, and soil, and it's usually the first hit. Then look at the soil acidification page on the left-hand side.
Wonderful. Thank you, guys. And so if there's more questions for the people in the public, we will have the breeders on. They'll be on between 2 and 3 this afternoon if you want to get into specific varieties and some of those different recommendations. So thanks for bringing that attention. And I'd be remiss if I didn't say that all the researchers you see on your screen today drive huge collaborative work. And that's just one example of what you're seeing here is between breeders, between pathologists, between soil scientists, microbiologists. We all push on the same side of the rock and try to move Montana agriculture forward. And that's a pretty proud thing for me to be able to say because it is a team effort at Montana State University and we're here for the producers. So Jed, we're going to take a little bit of a step back, and a producer from Liberty County is asking that in recent years, most of the hype about soil health has been with cover crops, and how the cover crops impact soil health, and how do they fit as a replacement in fallow when we don't get more than 7 inches of rainfall in our growing season. Could you talk a little bit about your work you've done with cover crop and how you see that impacting it, please?
Yes, that's a really good question, and it's one that's very relevant to producers around the state. I can't speak so much to the water use component or the yield component, either of the cover crop or subsequent wheat yields, but speaking specifically to interactions within the microbial community, the results really are quite variable. We do see some evidence that by increasing diversity through incorporating a cover crop, you have greater species diversity in your crops that you're growing. That can have a benefit to the soil microorganisms, but it's not consistent across all locations, regions, or cover crops. In general, though, it does seem to be a good thing. We are seeing in some of the work up at Northern Ag Research Center that incorporating some warm season crops does seem to have a benefit in increasing the microbial diversity and specifically increasing a few of the beneficial microbes that are present. Now, one of the things we're still trying to sort out is this benefit due to the fact that we have warm season cover crops in the mix, or is it simply more of a timing issue of when those crops or those cover crops are being planted? So when you're looking at some of our cool seasons versus the warm seasons, you can have a fairly big time difference there between when they go into the ground. So that really impacts the amount of root biomass that's present later in the season, given the available moisture. You know, if you're planting later and you don't have sufficient moisture, you could get less biomass in the soil there. So there's a lot of variables that play into this. In general, though, I would say the results are positive in terms of benefiting the soil health, but there's a lot of subtleties that go into that we're still trying to better understand.
Thanks, Jed. Clayton, you work a little bit with cover crops. Do you have anything to add to that kind of thought process?
Sure. I mean, it's a good question. Can cover crops really make it here in Montana where we have low precipitation? And certainly economically, work done by my colleague Perry Miller would suggest when we spray out cover crops in a no-till situation, it's really hard to make them pay because of the cost of the seed and the management and relatively small benefits to the subsequent crop, and often a detriment to the subsequent crop because of water use. Where we think cover crops might have a fit is more as an annual forage. Work done by Darren and others up at Northern Ag Research Center have looked at the effects of grazing and haying versus spraying out. And at least preliminarily, it doesn't look like removing that biomass has a really, that above ground biomass has a really detrimental effect on soil health, which is a good sign because certainly haying and grazing have an economic benefit.
Yeah, that's a good point, Clayton. We will have livestock interactions later on today. I believe that's between 1 and 2. And although we're doing a full economic analysis with George Haynes and Anton Beckerman of an 8-year cover crop wheat rotation trial, it looks from just cash receipts that adding livestock, specifically beef cattle, to our grazing, as a grazing a cover crop was able to compensate for the wheat drag the following year with the water use, to get back to the question or the comment you had, Jed. So we can sure talk about that a little more later on. But definitely, I think integration of livestock or hay an option to offset that until we can build that, you know. And can you talk about how that change occurs, Clayton? You know, we have a pretty good documented track record in Montana of, you know, increasing organic matter when we went from cultivation to no-till. So how do you see it as a soil scientist, us changing as we move into maybe this alternative cropping systems or cover cropping, and how long or what we can predict maybe on how we have to get on the train and kind of follow a plan to change organic matter or to change our soil profiles? Maybe Jed could jump in on that one also.
Yeah, take home message is in a low rainfall area like Montana, it's very hard to change soil organic matter. And the reason for that is we just don't return a lot of biomass to the soil. Preliminary work by myself, Perry, Rick Engel, has estimated that maybe 40% of the biomass that's returned ends up as soil organic matter. But when you start with something on the order of, say, 15 tons of soil organic matter per acre in the soil, and you're returning on the order of maybe 1 ton per acre, and then 60% of that actually ends up decomposing and going to the air as carbon dioxide, you can envision it takes a long time. We are able to detect change in our long-term trials where we convert from fallow to recrop or perennial or cover crop systems, but usually only after about 6 to 8 years can we really detect change. So the take-home message is it took a long time to decrease soil organic matter. It's going to take a long time to increase it, but if you're patient and you look decades to centuries down the road, it's certainly doable.
Great.
And Darren, if I could follow up on what Clayton mentioned about termination, one of the things that we've found in this study is that there really seems to be no difference in the microbial community profile if you terminate by chemical methods versus grazing or removing it as hay. So I think that's really a positive thing in the context of making this profitable for the growers, that if they are wanting to harvest it for feed, it's really not going to have a negative impact relative to chemical termination.
Great.
If I could comment from a
Please.
plant pathology perspective. So I get this question a lot for people who want to do cover crops, and that's if they have peas in their cover crop mix, are they going to build up inoculum to make their root rots worsen their pulses in the future? And that's a question that we're definitely looking at right now. I'm working with Audrey Carlisle over at NDSU. We have 1 year of data looking at root rot in cover crop systems of peas, and we found that it was significantly lower than in our monocropping systems. So I'm hoping to get some more years of data out of that so we can really answer that question for producers, because that's the last thing we want to do is make it more difficult to grow the actual crop.
So Frankie, that brings up a question I get quite often, and maybe you could answer this from a pathology standpoint.
Sure.
The rotational requirements or the rotational recommendations between peas and lentils and insurance reasons kind of takes cover crops out of it if there's any kind of pulse pea or legume in there, right? So how do we talk about that, and how do we think about that? And the work you're doing, is there any other historical work you know of to help us make that decision on how to do that? Because they kind of want the legumes in those cover crops.
Right. Not that I'm aware of. I'm sure they're doing work out of Canada. They have very much more strict recommendations for rotations in Canada, 5 to 7 years between lentils and peas. Lentils and peas being the same under the soil. Microbes see them the same, so it's pretty much the same conditions. Here we recommend 3 years. But like I said, the answering that cover crop question is really important. Though I have not heard is it considered that for insurance purposes? So I think is where the question really comes out. Yeah.
Being able to, you have to be a certain number of years, and I've forgotten how many years between the cover crop, even if it has peas in it, and that. So that's important data I think we need, not just as producers, but for an industry as a whole, including the insurance. So thank you. Good point. Yep. So Clayton, this brings up another question I hear from Plentywood, or we're getting from Plentywood, is what can we expect if we're returning this biomass to the soil, whether it be a pea crop or whatever, on beneficial nutrients to the next crop, and how can we see that happening, or what's the speed of that?
The beneficial nutrients can be a faster response, especially if there are legumes either in the crop or the cover crop. We think that legumes pulses fix on the order of about 100 pounds of nitrogen per acre per year, depending on moisture. We can be much higher than that and somewhat lower than that. Most of that nitrogen leaves in the form of grain. peas and lentils. Chickpeas are very good at getting the nitrogen into the grain to help the next crop. And that means we might be leaving behind something on the order of 40 pounds of nitrogen per acre from a grain crop. Of that, a lot becomes soil organic matter. So that's why we only credit following pulse crops somewhere around 10 pounds of nitrogen per acre. Following a cover crop might be, that's heavy on legumes, might be more like 30 or 40 pounds of nitrogen per acre. So there can be more immediate benefits nutrient-wise than the long-term buildup of soil organic matter. Did that answer your question, though?
Yeah, I think so. I'm sure the person will redirect if we need it. And I think my interpretation is how to get that nitrogen credit from growing the pulses the previous time. So I think you did good. So Jed, a question coming in. I didn't say where this location was, but you mentioned the Haney test and the cash test and some of this. So could you talk to a little bit about how producers should be going about testing and some of the soil microbiology work and how you would recommend them doing those tests, or if they want to get involved with that, or when they should?
Yeah, so a lot of the soil testing labs are starting to offer some of these additional soil health tests. They're being promoted from different sources. Basically, it'll require some additional sampling or slightly different conditions when you're doing those sample collections, depending on the test that's being run. But with a lot of these anymore, you can submit it to a service lab, and they're going to provide the results back for you if you're asking for something like the Haney test or the cash test. Getting into the specifics of what some of those tests do, a typical component is looking at respiration rate. So for those tests, they're basically taking a sample of soil, they're wetting it to stimulate the microbial activity, and then you get this burst of carbon dioxide that's produced, and they measure that. And there's a relationship between that carbon dioxide that's produced and the number of microbes, of active microbes that are present in the soil. So there's others too that look at things like the potentially mineralizable nitrogen, also looking at the carbon and nitrogen fractions that are associated with the microbial biomass in the soil. And often with those results, they will give a recommendation or somewhat of an interpretation of what this means in the context of the health of your soil. I feel like this is an area that is really still growing. It's quite new. A lot of growers in our region are probably not familiar with these tests. I am aware of some that are using them routinely. But again, it's what I see this as being another piece of the puzzle. And the more pieces we can add to the puzzle, the more complete the picture that we're able to see of our fields. And again, there's a lot of variables that go into this. Just to build a little bit off of what Clayton was talking about, because I think this ties right in, wondering how much nitrogen credit you're going to get back from your cover crop. Well, there's a microbial component to that. If you have a soil that's very degraded and low levels of microbial activity, it's likely going to take longer for that nitrogen to be turned over and made available to the subsequent crop. Where if you have a field that's been under practices that have really promoted soil health and it has a very abundant and active microbial population, some of those nutrients might be turned over much more rapidly. So some of these soil health tests are really attempts to try to help us understand what that potential is there. And as we look at things like potentially mineralizable nitrogen, and then also with the CO2 burst test, getting an idea of the microbial biomass, we can start putting some of these factors together to give us a better understanding of the health of our soil, but more specifically, how things like nitrogen will be cycled and made available to our subsequent crop.
Great. Thank you, Jed. Frankie, in from Daniels County, can you predict, and you might have to do some preliminary work in explaining this a little bit, but can you predict or have an estimate of what the vomitoxin levels may be come harvest time as we're moving through this year? And maybe you should explain what vomitoxin is.
Okay. Vomitoxin, which us researchers commonly call Dawn, so it's the same thing, is a mycotoxin made by Fusarium hebelite in that disease. It's not cancerous or anything like that, but it does cause feed refusal in certain animals. And it can make people sick. So there are limits when you take your grain to the elevator on how much vomitoxin that you can have. Unfortunately, I cannot predict how much we're going to have because as with most plant diseases, it's very weather dependent. If you are in an area and you have it, you went out and you saw it, and you know that you have it out there. If we continue to have high humidity, if you're continuing to irrigate, then it's going to get higher as the season progresses. So knowing that you have it is the first thing, and then you can start making decisions, and you can start deciding how much you're going to clean it. Because if you know you have head blight, highly recommend cleaning your grain thoroughly before you take it to the elevator.
Thank you, Frankie.
Sure.
I'm going to jump in with a question myself, because each one of you today has spoken a little bit about different management techniques for what I would call like an integrated management things for each one of your disciplines. Maybe if each one of you could address some of the things that your recommendations to help the pathology, Clayne, maybe on the nutrient profile and some of the things that you work on in your program. I think I'm seeing a trend of diversification, integration of other alternative methods of farming, cultural practices. If you don't mind, could each one of you kind of maybe address some of the things you should be talking to producers about and maybe should be considering and integrating in their system? And let's start with Jed. You look a little lonely there, still in Moccasin.
All right. Well, one of the things I would emphasize is soil testing. I know it's expensive and it takes time and it can be hard to fit it into a busy farm schedule, but it's really essential to know what's going on. I was speaking with a grower here just this week who had done some sampling to look at the microbiology within his field, and was surprised to see that in a particular area there was quite a bit of variability in the pH, one area being quite a bit lower. So I encourage you to go back and follow that with some more thorough sampling across his field, and rather than just looking at pH, let's see what some of the other nutrients are. And he also discovered in doing that he had a lot of variability in his nitrogen. So I've also been working with him to do some of the microbial community analysis as another piece of that puzzle to try to figure out what's going on in different parts of his field. So I just use that as an example. You go out and pull a few soil samples from your field, gives you a little bit of a picture, but as Clayne mentioned, specifically with the acidity, it can really vary across the field. That can also occur with a lot of these other parameters. So just the importance of sampling. And also too is moving forward as we're more aware and focused more on sampling related to soil health, think about the questions that you're trying to answer with the sampling. It's not really sufficient just to say, okay, I'm going to go out and sample everything and do every possible test under the sun. But in the context of your management practices and what you're hoping to achieve with your land,
precision agricultural management of specific soil testing is that kind of what you're thinking, Jed?
In a sense, yeah, it really does play into that.
Great, thank you. Clayne.
Yeah, follow up on what Jed was saying. I know sometimes he did mention the cost of soil testing. I see soil tests somewhere on the order of about $40 per test. Often that's done per about 100-acre field. You do the math, that works out to be 40 cents per acre. Often we find nitrogen levels that might be 10 to 30 pounds of N per acre different year per year. You run the math on over or under fertilizing by 10 to 30 pounds of nitrogen per acre per year, and that soil test easily pays for itself. So as far as integration, you probably heard a lot of people talk about the 4 R's, meaning you have to apply the right rate, source, placement, and timing. If you focus on just one of those, say rate, and don't think about where you apply the nitrogen or the phosphorus, the potassium, you might be wasting some of your fertilizer dollars. I also like to add a fifth R, which would be the right rotation. And so as we've all been talking about, rotation really plays heavily into good fertilizer management. By using a range of crops, we end up helping with disease. By using legumes, we end up reducing nitrogen needs. And so it's really important to think about those five in concert. I think in Montana, with a lot of hard red wheat being grown, we probably focus on nitrogen a little too much, and I'm partly to blame for that. I talk about nitrogen a lot, but what I'm seeing is a lot of producers who say, I'm not getting the protein I used to get. Why? And when I look at their tissue tests or their soil tests, a lot of times another nutrient is low. For example, sulfur is also needed to make protein. So really looking at all the macronutrients and the micronutrients, where they're applied, how they're applied in concert with rotation, I think is really key for good nutrient management.
Outstanding. Thank you, Clayne. Frankie.
Okay. Well, I would say, Jed and Clayne and I probably agree on just about everything except for one topic, and that's tillage. So, no-till systems have been great for improving soil health and preventing root rots, and that microbial diversity is incredibly important. But if you're having problems with a residue-borne disease, then dealing with that residue becomes very important. So if you're you're growing cereals and you're having problems with tan spot or head blight, or if you're growing chickpeas and you're having problems with Ascochyta, then minimizing your residue on the soil surface becomes incredibly important. And that's the time to really look at and see if maybe a light disking or breaking up that material a bit would be beneficial to you. So I don't ever recommend a hard and fast no-till system. It's look at the situation you're in, look at the problems you're dealing with, whether it's plant pathogens or weed issues, and make a decision based on that as well.
Outstanding. We just got a couple minutes left, and I want to thank you all for this, but I have one more question that I guess they're pointed at me, so I apologize to our questions here. Is Bob from Conrad asks that there's been several recent departures in the research centers. What's the current status and what does it look like in the future? And Bob, I want to say thank you for the question. I feel bad taking away from our panelists here today, but it's very important. The research centers have just recently hired 3 new faculty members. This is in some very difficult times with the pandemic. The Board of Regents did put a hiring freeze on all positions throughout the university process. However, we were able to petition through my office, through Dr. Bajwa's office, up through the provost and the Board of Regents, and they supported 3 new hires out in the fields where there's boots on the ground for research. We have a new weed scientist starting at Southern Ag Research Center, Dr. Livrit Shergill. He'll be taking over for Prashant Jha. He'll be working on specifically on herbicide resistance, crop rotations, and herbicides as a weed scientist. At Conrad Station, we just hired Dr. Justin Vetch. He'll be taking over both a new faculty position and the superintendent position in Conrad at Western Triangle. That's an outstanding hire for us. And over in Northwestern Ag Research Center, we just hired Clint Byerman, who is going to be a cropping systems agronomist. However, he has a weeds background and is very interested in them, or maybe those smaller acres, high dollar return on a high moisture regime in Northwestern Ag Research Center. So I appreciate the question, Bob. I appreciate everybody keeping us on task and making sure our staffing at the research centers, and I would include all of maize, is very important to the producers of Montana. So that's our current status. If you have other questions, feel free to contact me. My email is dboss@montana.edu. My door's always open. I'm happy to field any other questions any other time. I'd like to go around the room, and if you don't mind, Frankie, how can people get a hold of you?
Well, I'm over here at the Eastern Ag Research Center, so you can email me at frankie.crutcher@montana.edu.
Thanks, Frankie. Jed?
Yes, and I'm here at the Central Ag Research Center up by Moccasin, and you can reach me at jed.eberly@montana.edu.
Clayne?
You can reach me at Clayne J, CLAINJ @montana.edu, or call me at 994-6076 with any soil fertility question.
Boy, thanks so much today for being with us this past hour. It seems like it was 5 minutes. I don't know about your end, but it seems like we did really good. Some outstanding questions. I will follow up with the three of you if we have any questions come in that may pertain to you or interact with the breeders. And with that, thanks so much and have a great day.
Thank you.
Thank you.
For the general public, we're going to be taking a short break so we can transition our speakers into the next group. So we'll have to shut down for just a short bit. Hang on there. Doesn't mean you have to shut down the YouTube feed. We're just going to cycle people in and out. Thanks so much. Have a great day. Good morning, Montana. Welcome back to the Montana State University Montana Agriculture Experiment Station virtual field days question and answer scenario from 10 to 11 o'clock. We have 4 new contestants and participants in our program this morning. Want to thank you for all your participation and good questions from the previous hour, and keep them coming in. At this time, I'm going to introduce our individual speakers today. And Dr. Chen-Si Chen from Eastern Ag Research Center in northeastern Montana. Dr. Kent McVeigh from Southern Ag Research Center. Dr. Jessica Torian from Northwestern Ag Research Center. And Miss Peggy Lamb for Northern Ag Research Center up on the High Line. So with that, let's go to Chen-Si. And Chen-Si, you want to give us a quick update on who you are and what you do?
Okay, thank you, Darren. My name is Chen-Si Chen. I'm an agronomist and a superintendent at the Eastern Ag Research Center. First, let me give you some information about the research center in Eastern Encini. So our research center has 2 farms, one dry land and one irrigate farm, and that allow us to do both dry land and irrigate research. And the research center has 2 research programs. One is the plant pathology research program led by Dr. Frankie Crutcher, and I am leading an agronomy research program. So for agronomy research program, I have been doing a lot of variety testing. So we have both on-farm and off-station variety testing for wheat, barley, durum, pea, lentil, chickpea, canola, and sugar beet crops. And besides, in addition to the variety trial, we also do some fertility study for sugar beet. So I have a project that try to do no-till planting for sugar beet, and also try to figure out what's the nutrient management strategy for no-till sugar beet. And for alternative crop, recently we start variety testing and seeding days for industrial hams. And we also have another project working on mung bean and azuki bean, try to develop some warm season alternative pulse crop for Montana. So that's all I have, and go back to you, Darren.
Thank you, Chen-Si. Let's go to Jessica up in the northwestern part of the state.
Good morning. My name is Jessica, and I'm located at the Northwestern Ag Research Center. I was hired 6 years ago as a field crop physiologist. Basically, my program cut across disciplines. I have programs that are dealing with nutrients and then dealing with moisture regime or water productivity, and then these 2 things also intersect. So I'm looking at interaction between these 2 large input of production, nutrients and water. 3 years ago, I became the superintendent of the Northwestern Ag Research Center. So I, just as others, we wear multiple hats. I've got a tried breeding program as well, working with the breeders. Now we ventured on alternative crops, increasing the amount of study for forages. This year at the northwestern side of Montana, we started off a bit cooler and a bit more of rainfall that we received. And then in August, last week of July, we warmed up really quick. So we might be able to harvest our winter wheat here pretty soon, maybe next week. So now I think we're catching up with irrigation as well. So if you have questions with regards to nutrient management that cross over water productivity and stuff like that, and alternative crops, I will try my best to answer those questions based on what I only do. But I guess that's the general update on my program. The one thing that we're excited here is we have a new faculty member, Clint Byerman, that will focus on the cropping system side and also the biotic side of research because my program was on the abiotic, meaning the non-living things like water and nutrient. So that's it for me for now.
Thank you, Jessica. Let's make another X all the way across the state of Montana to Kent McVeigh. There you go. You got to hold it down. You're still muted.
What if I hold this down?
Perfect.
All right. After you knew how to run this thing here. My name is Kent McVeigh. I'm at the Southern Ag Research Center down near Billings and at Huntley, actually. And I'm the extension cropping system specialist for the state. And so I do a little bit of research as well. Here at the station, I do all the off-station trials for variety trials for spring wheat, winter wheat, barley, peas, lentils, chickpeas. And we do that all around the region and then also on station. We have a few rotation studies over the years. I've got a new one I just started about last year where it's a strip crops. We have 11 treatments, and then the second year we plant perpendicular to that, so we can look at the rotations of wheat on winter wheat on crops like flax or like following peas, those kinds of studies. I have a cover crop study that's been going on for about 6 years, and fertility study. We've done some work with Jamie Sherman with the breeding program at barley and looking at nitrogen response of those barley crops. She has some low protein genes that she's added into some barley rice. So really just doing an evaluation of those. I've done a little bit with water use efficiency. We've got a study, and actually Chensi's got the same study duplicated at Eastern, looking at water use on peas and chickpeas, and then I added in wheat just as a comparison. So we can talk about any of those issues.
Outstanding, Kent. Thank you. Let's go north to Peggy. I hear harvest is underway at the Triangle.
Yeah, so am I muted?
Yep, you're good.
Okay, so I actually started harvest on Monday. We harvested some peas Monday and got into winter wheat yesterday. Several pea trials out and winter wheat trials out. I'll back up, introduce myself to you guys. I've worked for Montana State University for 21 years. I've been at Northern Ag for 18 years. My program focuses mainly on variety testing and variety development, but in any given year, I have 25 to 30 different collaborators. You may have heard Plain Jones earlier. Beyond the 5 breeders, crops breeders at Montana State, I also do help out with fertility trials, seed treat trials. We have a lot of wheat stem softfly up here, so our station is the one that both private industry, Montana State University, Washington State University, different universities come to for screening their either products or their varieties or their developmental lines in a wheat stem softfly environment. We do a lot of alternative crop testing. If somebody wants to find out if their crops can grow here, we have some Brassica gensea again with a private company. It's grown well here in the past. They're trying to get it to market in the States, and we jump back in this year and have collaborative research and variety testing for those guys. We service a 5-county area up here, so we have, like Kent does in his part of the county or part of the state, we go off station with our winter wheat, spring wheat, and Durham testing to Phillips County, Loring to Turner, down to Loma, Big Sandy, Chester, try to help out with anything, anywhere that we can, wherever it's a fit and what we can make fit into the program. Our off-station testing, the growers of Montana, the cereal producers of Montana are ultimately who pays for this through their checkoff dollars that are administered through the Montana Wheat and Barley Committee. So we have to put a huge shout out of thank you. We could not be doing any of this off-station research without that wheat and barley support that we get through a grant that we write every year to help partially support this off-station work. We also do fertility testing. We submit proposals to the Montana Fertilizer Assessment Council. We get funding for that, again, through checkoff dollars. And this really helps with research throughout the state of Montana. So we got to have shout out a big thanks to that council also.
Wonderful. Thank you, Peggy. The first question actually for Chen Si, and he dropped out for some reason. Must be a low bandwidth, so we'll get him logged back in and we'll come back to him. Jessica, there's a question here from the Triangle that asked the question about, you did some work on water regimes and wheat protein yields. Could you quickly summarize that and how that might impact what happens in the Triangle in a dryland environment versus an irrigated environment?
Yeah, sure. Thank you for asking that question. So there is definitely a relationship between a high yielding environment when you try irrigating wheat. First, I will talk about the generic aspect of it, and then I could go down to the specific trait. Say, for instance, stay green versus high grain protein like Egan that we've had before. But first, generally, when we irrigate wheat, especially if you irrigate it well and it's no stress type of watering, that would mean that the yield would increase and the protein level would also decrease. And that is because of production of carbohydrates in the seed, and some of them get diluted when you have too much productivity in your system. On the other hand, if you have a rain-fed environment where your number of seeds per head or the number of spike per unit area of land is limited because of your drought or your limited watering environment, then your protein would go up. And it is because in that environment, your yield is low. So it's a kind of a fine balance that you have to do. What we're finding is watering is really sensitive from tillering stage to flower. You could, apply more irrigation at milk, but I think applying more irrigation sometime in the medium milk to close to soft dough is actually a bit counterproductive because for one thing, the response is very little or none. And so in that respect, you may be just adding water for not very good response in your irrigated system. But at the same time, it doesn't do anything anymore for yield. So, with falling number, also that's kind of a different story where when talking about quality, not just protein, but falling number is where there's an enzyme on the seed that acts on the seed and converts basically starch into sugar. So that's one thing that we are discounted when we deliver our grains to the elevator. And so when we, during a wet environment, for instance, on a rainy season towards harvest, the falling number would go down. That means that's kind of critical for discount. But also when you irrigate later in the season too, your falling number tends to go down. So that's one of my purpose of the research program that I do is basically developing a simple rule of thumb in a way, because irrigation is a combination of science and art, right? So at some point when science becomes complicated, we look at the art side and look at the rule of thumb in terms of what aspects of production are going to be affected. So that's kind of the general sense of the of irrigating wheat. The one thing though is that when you play with traits, for instance, like stay green trait will definitely yield more compared to other varieties like Vida, for instance. The thing with that is that if you irrigate it for more later on, then it will remain green, and then you have low protein. With Egan, for instance, that has high grain protein content, even if you irrigate it for longer, it will still have grain protein that is at least 14% and above. So that's a difference between those traits. And as I said, one of in my program, I'm kind of crossovering, agronomy and also different traits. So I think I will stop there.
Thanks, Jessica.
Hey, can I ask a question about Jessica?
Please.
So lodging issues with irrigated wheat or irrigated barley. Seems to me it's water, late water more than nitrogen. Sometimes people blame it on excess nitrogen. Actually, I have a nitrogen study with Jamie, and I've got 2 times the rate that we actually need, just so I have this response. And I'm seeing no lodging in that barley where it's nitrogen, but I do see lodging in wheat when we irrigate late. And I was just wondering your thoughts on that.
Yeah, so thank you for that question, Kent. So lodging is a mechanical, it's related to a kind of a plant. If the stalk is not very sturdy enough or it gets really tall, and also there's a mechanical aspect of that, right? When an overhead sprinkler hits on that multiple times. So what happened is lodging is kind of like a domino effect. So once when you have a sprinkler on and a group of plants are lodged a little bit, so it's a domino effect, and they're going all together like this and lodged at a certain angle. But you are right. I think the nitrogen level that I've observed is just extending the green tissues. But lodging is water has a little bit of contribution to lodging. And if you remember, if you look at the grass as a species, it has a node to node, right? And you have a stem. What happened is, say for instance, June, and you like to irrigate because, my electricity will get cut off because it's, in a normal year, your June temperature gets really high. There's demand for other uses like the urban dwellers. And so you get cut off, your power supply get cut off. And this is the question I've been asked with a number of producers before, like, what do I do because my power supply gets cut off? So I'm just gonna irrigate here until I can and then stop later. But the problem with that is that this node to node of a grass species is that when you have a lot of moisture and the temperature is high, this node is extended really longer. And so that is when you tend to have a taller plant when you have good moisture amount and high temperature. And so I think you're right. Here in our production field, I asked our farm manager to stop irrigating already when we have, milk, because as soon as there's a repetitive action of the sprinkler and one plant would lodge, as I said, it's a domino effect.
Perfect. Thanks, Jessica. Thanks, Kent. Good questions. Welcome back, Chen-Si. We're glad you're back. The first question right out of the bunch was for you. There's rumors that you had industrial hemp trials at Eastern Ag Research Center. Can you talk a little bit about those and how you see that fitting in Montana? You're muted.
Okay, I'm sorry. Yeah. It's not a rumor. We do have an industrial hemp trial at Eastern Ag Research Center. So we started to study the hemp since 2019. So basically in 2019, we did a variety trial and a seeding date study under irrigation. So the 2019 the trial meaning for the hemp that have a dual purpose, either for grain production or for both grain product and fiber production. So we found that seeding day is critical for hemp production in Montana because particularly for the seed production, because we have to seed early, as early seeding will produce higher seed yield because we have a short growing season. So if you plant too late, probably ham will not going to mature and produce a seed. In 2020, actually, we have additional two variety trial. So one is a variety trial for grain and fiber production. The other trial is strictly grow ham for CBD production. That's those are people you grow hams. You need to know what genetic used for what purpose. So the grain and fiber and CBD production, they are completely different genetic. So any further question on that?
Nope, we'll see what comes in.
Okay.
Thank you, Chensi. Kent from Cutbank. They said they were driving down the road and saw flax and chickpeas being planted together. Can you talk about what that adds to a cropping rotation or what's happening there, please?
So this was a practice that's been gaining popularity in Canada. And actually, I know Chensi's got a study, and we have a study here where we've intercropped flax and chickpea. And the idea is that the flax will reduce the movement of Ascochyta across the field. And so that's why you're seeing that. I don't know that we really have the data to say that it actually does. I don't even know if Canada really has the data to say that it actually does reduce that movement, but that's the theory behind it. And so those plots are pretty important for us to evaluate here at Huntley and also at Eastern to get some data here in Montana to see if that really is an effective practice or not.
To follow up with Ken's comment on that, we do have a plant pathologist, Dr. Frankie Crutcher, actually is a team member for this project. So she is evaluating the incidence and severity of the Ascochyta for this intercropping trial. And we have a graduate students try to use the sports trap to see actually we can track to the spore movement from the chickpea to other plants. So, yeah.
So if I could follow up on that for both Kent and Chensi. So what you're saying is the goal to increase number of years to grow chickpeas, or just a preventative measure, or is it what's the theory behind? I mean, I understand Ascochyta not moving across the field, but what ultimately is it going to let them grow it more often, or just prevent it from when they grow it?
Okay, that's two purposes. So one is because if you use a herbicide, we try to reduce that use the fungicide. Okay, so if you use the fungicide again and again, probably can produce develop the resistance to the fungicide. So that's one purpose. The second purpose is for organic production. You don't have the option to use a fungicide to control Ascochyta, right? So the idea is if this can intercropping flag with the chickpea can reduce the disease incidence or severity, then probably this practice can use in the organic production system.
So I have a follow-up question for that, Chensi. When you, or Kent, when you guys are seeding it, or when guys are seeding it, they're harvesting both seed, the flax and the chickpea, and then separating them?
Yeah, that's the idea, is that you'll harvest it together and then take it back and screen out the flax, and it's pretty easy to separate if you have the cleaning equipment to be able to do it.
Right.
So you get both crops as, you know, as something that you can economically benefit from. One of the questions is what kind of seeding rate should you have? How much competition is flax going to give to chickpea and vice versa? I mean, mostly chickpea is probably the biggest money maker of those two crops, but you don't want to really severely reduce your chickpea yield. And so that's the other study that's going on, is just rates to see if they can really predict what the impact to yield would be.
And what about every other row versus seated together in the same row.
We have,
That's also part of the study.
yeah, Becky, we do have, it looked like alternate road work better than a complete mixed configuration. So yeah, Becky, Peggy, thank you for the question. Actually, the separating flag from chickpea is not the issue. I think the major challenge is harvesting them, how to set the combine to stretch both flax and chickpea, because the seed sizes are so different. So if you adjust too tight, then we're probably gonna crash the chickpea. So is a challenge. Yeah.
Good point. Good discussion. It sounds like the jury's still out on intercropping those two crops, but we have work on it. So thank you for all you guys doing the work on that. So Peggy, in from Kremlin, Montana, what is the status of the winter broadleafs? What's living, what's winter killing, and do you have any updates on that?
So on the winter broadleaf side, that was one of the things that we harvested on Monday. We here at the Research Center planted winter pea from Kevin McPhee's breeding program. He has been working on breeding winter pea for our area. And 2 years in a row, we've, excited that we've actually been able to harvest seed from these winter peas. This year, more than last, we did not have a great winter with great cover here in North Central Montana. So I really think if we were going to kill a lot of winter peas, last year would have been a great year to do it. Some of the plots looked really, really good. Other, not so much. So I'm very hopeful for that breeding program, that we can get something released, that Kevin's program can get something released, because his lines are doing very well. He's taken selections, and we're going to seed it again this fall. We haven't had winter canola here in 2 years, but there were winter canolas from the program in Kansas. These are grown also down every other year, I believe, in Bozeman. They made it through the winter. I don't have yields on those. I don't know that yields were taken. It was just put them in to see if they would make it. There is promise for the winter canola up here also, and breeding programs are working on them. Jamie Sherman's program, she's also working on winter barleys. We have not grown any of those up here, but very hopeful that would be another fall seeded crop that we could get into.
Thanks, Peggy. And just a plug, we will have the breeders here between 2 and 3 o'clock on the YouTube live channel. We'll be able to ask specific questions of those breeders on those programs. And I think Chen-Si, Kent, you both have a little bit of winter stuff too. Do you have any other comments on winter broadleafs?
We tried it. Winter camelina, it can survive here. Winter camelina right now seems not much market. However, there's a lot of interest using winter camelina as a cover crop. So that do have a potential, and that do able to survive our winter in Sydney area. We tried winter pea and winter lentil. Look like a winter pea, that's survivability pretty low. Probably now actually the Kevin's breeding program and USDA Pullman program have newer lines, might have better winter hardiness, but we haven't tested that. But winter lentil doing very well here. Again, winter lentil can survive here and have potential use as a cover crop or just harvest for seed. And along the Yellowstone River, that region as a winter lentil can do very well. So, yeah.
Kent?
Yeah, I don't have any broadleaves for the winter, but I know that there's some producers growing some winter lentils down through over towards Hysham, and when our last weed scientist had some work with winter lentil, was quite successful here.
Jessica, do you have any winter broadleafs over there you're playing with?
So not this year. I think the one thing that we learned here in the northwestern side is we learn from the producers. As you traveled, maybe if one of you guys had a chance to travel at the this side of the mountain, there are years where winter canola are really surviving, and it's great in production fields. And so we learn from the producers out there. And this year, actually maybe 2 weeks from now or a week from now, Clint Barman, our new cropping systems agronomist, is getting ready for a winter canola trial. He got seeds from the Kansas breeders and also some seeds from the industry to do planting date experiment, because as the sages was what really wanting us to do is to plant winter canola in August 1, and I'm not sure if that fits to our cropping system. So, but we try our best this year because it may be that we're able to cut our production fields like winter week next week, and we could break the grounds as quick as we can, and maybe we could pull it off like a first week of August winter week canola planting date. So we're excited about that because one of the survivability during the winter really is the amount of root reserve that you establish before winter, and we don't know that yet over here. So I was asked before to do this kind of experiment, but I didn't have a chance, and now we're excited that Clint is going to do that, and we're looking forward to the outcome for next year.
So what Jessica just mentioned is a really tough thing for here in Havre, around the state. Jessica has water, she can irrigate things up, maybe, and more rainfall on the western side of the state.
Mhm.
If we turn around, even in our fallow ground right now, if we were to plant anything, if we were to plant our canola or our peas right now, it's not coming up until we get rain. And if we don't have enough rain to get that root established to the point that, if it only rains enough for it to sprout and then it dries out again, it's dead before it gets started. We can get it irrigated and get things up. It's a whole different story. So even if we were to plant August 1 or August 15, we normally don't get rain until the end of August or early September. And we need that moisture to get these fall plants established and going. Kent or Chensi mentioned winter camelina. We've had winter camelina here at Northern Ag. It grew very well 5 to 8 years ago. We haven't been testing it since. And on the winter canola side, down at Fort Benton, there are a lot of growers around that are doing a very, very good job growing winter canola in different areas. So.
Great. Thank you all. Good discussion. This in from Sanders County goes to you, Jessica. They said they heard you're growing Kernza. What is it, and what do you see it happening in Montana?
So yeah, this is our first time that we tried Kernza, and this is, I give credit to my research associate that's more excited to try it than me, because I thought, we have to wait for a little bit. But so we tried planting Kernza last September. So we had, because we don't know yet how they would be established, so we tried different planting dates. But really, Kernza is a trade name that's used by the Land Institute in Kansas. They've researched this Kernza for over 15 years now. So it's an intermediate wheatgrass that originated in Europe and west of Asia. And I think this was brought in the United States for dual purpose type of alternative crop. So you could either use it as a forage or as a grain. And this has been really popularized in Kansas and even in Minnesota. And I think this has been supported by the legislature too, in terms of their strategy in what they call constant greening, or I can't remember exactly the term, but they want to have green cover for the entire year. And so that's how it got popularized in Minnesota. And we want to try it here. The reason we keep trying alternative crops is that producers always want to find ways, especially if, the commodity prices are low, and making sure they diversify and have alternatives. So I'm happy to say that the Kernza that we planted in September and October are growing really good. And it just flowered a week ago. It's beautiful flowers. And we might be ready to harvest some forage samples and grain, maybe, I'm guessing, hopefully by 2 weeks from now. So it's kind of similar timing, really, when it comes to spring wheat. The one thing that we observe, though, is that if you plant it in spring, like April and and May. The plants are small and it's not headed, and if you take a look at that, it might require cold temperature to, just like your winter wheat, to head. And so we are still new to learning kerns as well. So we are excited to report to you guys what's our biomass and what's our grain outcome. I know that the Minnesota folks have started developing type of kernza that is has a human grade consumption, like, I don't know, for cookie or for malting even. And so, no, brewing, sorry, is that the right word? Yeah. And so, yeah, so I guess we're excited about that. It's still fairly new, but it looks like it survived well on the first year, and we'll continue making measurements for the following year and see how it goes.
Thank you. Thank you, Jessica. Kent, this from Choteau County. Can you, I'm gonna rearrange this question because it was really pros and cons of crop rotations in fallow and intensified cropping systems. Can you kind of go through the decision process that a producer needs to go through as they, one, diversify their operations with different crops and increasing their cropping intensity from crop fallow into more continuous cropping or flex cropping?
In dryland production?
I'm assuming, Choteau, yeah.
Well, you know, it's we've done studies here, and I know Chensi's also done some studies, rotation studies, that show that you can intensify from a winter wheat fallow system to a crop following winter wheat and go into a crop every year, and be as it depends on the economics of the year, and so the economics change every year, and so it really varies whether that's really economical or not. But there's a definite benefit to rotating, just mostly from a disease control issue and from a weed control issue. And so going, let's say, to peas following winter wheat, it's usually pretty successful because peas don't use a lot. They use a lot of surface water, probably down to 2, maybe 3 feet. And so you may drain the profile of water with a winter wheat crop, but that following, you know, that fall and winter recharge gives you enough probably to grow a decent crop of peas the following year. And so you can do that with other crops, with flax. You can do that with canola, probably up there in Choteau County. There's other crops that you need to look at the economics of the system, and you have to look at what you have for equipment as far as being able to plant and harvest. And most of these crops that we grow are drilled crops. So your same drill that you're drilling wheat can be used to drill most of these other crops. Mustard would be another choice that might work in there. The yield benefit from rotation is small, probably 5 to 10% max if you see, as compared to a continuous of that crop. And we don't really have good data to really evaluate that here. We can look at other states and see that, but I do have a rotation study. We started this last year where I'm looking at rotation of different crops, and we'll be able to see a yield response, but it's going to be compared to, the same crop planted. So certain crops you don't, like flax, for example, you wouldn't want to plant flax 2 years in a row. The second year, it really is poor compared to the first year. Wheat is not so bad, and it's probably because we have pretty good weed control issues. It's not as depressing to the following crop for wheat, but the oilseeds definitely don't like it from a yield perspective, but also probably a disease perspective.
Follow up Ken's comments. When you do talking about intensify your cropping system, you really need to look at what kind of precipitation you can get in your area, and also what kind of soil you have. So for deep soil, your summer fallow going to preserve moisture for next year. And for shallow soil, you probably summer fallow is not much benefit because your soil profile only store that much moisture. So you need to really, the growers need to be really careful if you have only less than 14 inches of rainfall, 12-inch rainfall, that your annual cropping going to be really risky. So you rather to unless you grow one season as a forager or something or cover crop. Otherwise, you probably consume a lot of moisture for annual cropping, not produce a economical yield. Like rather doing annual cropping, probably better to do the summer fallow to preserve moisture to get a good year's crop. So.
Thank you, Chen-Si. Thank you, Kent. Jessica, could you talk about your corn trial? Someone drove by and saw corn they're growing there. What's going on with the corn in northwestern Montana?
Yeah, so people were asking me, why are you planting corn there? And it's still up, in January. So, so corn is one of those things that has been brought up by our Farmer Advisory Committee. And that is because the south of the Flathead Lake, farmers have tried them before, and some of them are successful, except the drying down time could be problematic. So we started planting corn last year, and we only had 2 relative maturity that we tried, 75 and 80 days, and we tried 4 planting dates, actually 3. So we have late April, early May, and then 3rd week of May, around that area at time. So I think our goal is to really add to the knowledge out there in terms of the choice of relative maturity and what's our optimal timing, because as corn loves warm weather. It's a warm season grass, and so us planting corn in April is somewhat like questionable, but for the past 2 years now, corn has grown really good, even if you plant it in April. And I think what it is that based on research out there, is that there's a critical window of imbibition of moisture into the seed when you plant it. So I think for as long as your soil temperature does not fall below 50 degree within the 4 to 8 hour of planting, so you're kind of safe in there. There are, this year, May, for instance, had temperature that were lower than April. So it's a little bit of a story there. What we're finding is that when there's cooler temperature, there's a little bit of discoloration in the tissues, that plants are reacting to the cold temperature, but it recovers immediately. And so I think now, for instance, on our soil temperature, when we plant at the depth, that is a different temperature compared to our ambient, right? Usually soil will store more heat, and it's a bit warmer. But if you have a no-till ground, it could be a bit cooler than the ambient temperature. So that's the only difference. But here we planted it on a cultivated ground. So the soil temperature was a bit warmer than the ambient temperature by 1 or 2 degrees warmer. So we harvested for forage last year, and we have to do the same thing this year too. We also harvest them for grain. We harvested our corn grain. We let them dry down during the winter, and we harvested them in January. So everybody's wearing their coat, and they're nice, pick up the heads one by one, and we have fun harvesting those stuff. So I think if you're interested, we don't have much time. If you're interested with the data, just shoot me an email, and I could provide it to you in terms of the effect of the planting date, and also with the forage and the grain kernel yield.
Thanks, Jessica. Is that also on your webpage?
Yes, it's also available in the webpage. Yeah.
Thank you, Jessica. Peggy, this in from Liberty County. Havre has a different way of measuring severity of winters than other parts of the state. So it must have been a comment to your last comment. So how does a producer go about making a decision to put alternative crops in his thing in a triangle area where there is some different weather patterns than the rest of the state?
Very good question. I don't know if I have a very good answer, but I'll give it a try. So looking at alternative crops in our part of the state, look at what we're trying to do at the research center, check with extension agents. If there's something you think might grow, look to us for the research to see if we've tried to grow it before instead of just going out and planting it yourself. A lot of people want to do their own on-farm trials to figure things out, which is absolutely wonderful. Like Jessica says, we learn a lot from farmers too. And wow, we should have been doing this, or we need to try this also. Don't be afraid to look to see what your neighbors are doing, or what has worked for them. And then trying different alternative crops around. Know you have a market for it before you grow it. That's huge. Just don't, wow, this is selling wonderful. Grow it and then get ready to sell it, and you're stuck with the seed. So market is huge. Is the seed available to plant? What are your herbicides? I mean, there's a whole long list of things you need to look at before you jump into an alternative crop. Herbicide residuals, people that have been wheat on wheat, pretty safe with it. They're jumping into a lentil or a canola or something else. We need to be sure we know herbicide residuals and things like that. Kent kind of discussed, you can use your drill to seed it. Know you can actually seed it, and know you have the right equipment to harvest it. So markets are huge. Keep your acres small. Don't put everything in all your eggs in one basket, so to speak. So, and know, I guess, going into something that you have limited knowledge on how this is going to grow, don't have the highest expectations that you're going to hit that high yield, because it's something totally new, and it's a big learning curve when it's the first time planting anything. Researchers, we know that. We should know how to grow anything because we're a researcher, but the same learning curve for us, like the Krenza grass, the quinoa here that we've started to plant, how do we plant it? When do we plant it? Seeding rate, seeding date, how do we harvest it? Everything like that. So start small and know it's going to be a big learning curve for you. Don't hesitate to ask anybody and everybody questions.
Yeah, let me toss this out to the rest of the panel. Anybody else got any thoughts on the decision process? Or
I'd say start small is a really good comment. I had a guy down here, the first time he grew lentils, grew it on like 1,000 acres, and it was kind of a disaster, mostly because of herbicide carryover. So do it on 20 acre, whatever small is to you, 20 to 100 acres max, I think. Because if it's a disaster, you don't want a disaster on 1,000 acres.
good point.
Also, the growers actually ask about that the winter conditions are different in Haverhill and other places. Probably if that too harsh, you really need to be careful. Instead of looking for the fall seeding crop, probably look on the cool season or warm season spring crop.
Yep. So we're just about getting ready to our last. We're going to end at 10 till 11, so we can get the next group in here. I have a really quick question for Chen-Si. Chen-Si, what's one of the most important things? You've been researching pulses since you started at Montana State University, and this question's coming in from Petroleum County. What's one or two things when you grow pulses that make the most difference in yields and protein and profitability?
Well, cropping systems, okay, rotation. What kind of cropping system? And for the new grower, Ken actually mentioned that earlier. Becky also mentioned the herbicide in its history is really critical. And the second thing you need to, for annual cropping, again, need to look at the moisture, what kind of moisture you have, allow you to do annual cropping or not. So currently, the market kind of slow, so you need to really, particularly when you grow green pea or chickpea, make sure you contact the buyer, have a contract for the chickpea. So the growing chickpea need to be very careful because the seed is expensive and the price can low, and then probably have some risk of the Ascochyta, the disease issue can be very costly if you're not doing correctly. So.
Okay, we're about out of time, but would everyone of you agree that locally adapted research plays a big part in figuring out what alternative crops grow. And Chensi, even with your pulse questions, that's a pretty important factor that they get that data from the local research centers or wherever they're at.
We have variety trial at many research centers, and every year we have a report that published, that available for everybody. And also each research center like Peggy can all participate in a variety trial. You can get the information from them too. So
Perfect. Thanks, Chensi. Everybody's email is listed at Montana State University. It's montana.edu. You can look any one of our panelists up and get their emails. They'd be happy to field any more questions. And if they can't answer the questions, I promise you, they will get it to a person that can address that for all the people that are out there in cyber world. I want to thank our 4 panelists today for alternative crops, water use, and we've covered a lot of ground. Looking forward to them being harvested and getting the data out. And with that, thank you very much for all of you taking your time. For the people out there in YouTube world, we're going to take a 10-minute break so we can bring the next group into the discussion as we dismiss those. And once again, thanks so very much for being here.
great. Thank you all.
Thanks, Darren.
Thank you.
Welcome back to Montana's State University's Montana Agricultural Experiment Station's virtual field day question and answers. We've had some very robust discussions this morning, starting at 9 o'clock in the a.m. I want to thank everybody for joining us on YouTube. It's unfortunate that the current pandemic has caused us to take our field days online, but I can tell you there's at least 56 videos that have been edited and put on our webpage for you to look at, and there's some really great opportunities for educational chances there. I'm pretty proud of all the researchers and their staff and people that stepped up and made those videos. I can speak for myself and probably most of the people that we're going to have in the next hour is that, field days are outstanding amount of work, but it's one of the best days of the year because we get to spend time and interact with our producers, our ag allied industries, and although it's unfortunate that we can't be in person, we're going to give it a go online, maybe try and embrace some of the new technology, and we'll see how it goes. And for this next section, we have several researchers from Montana State University. We'll go quickly around the room. We have Dr. Perry Miller, whose base camp is in Bozeman, Kevin McPhee, also in Bozeman, Dr. Zach Miller from Western Ag Research Center, Dr. Pat Carr from Moccasin, and Dr. Abby Saeed down in Bozeman, who's our new extension horticulturist. With that, Abby, why don't you start us out?
Sure. Hi, I'm Abby Saeed. I have been on the job for just under 1 month, and I'm starting to learn about what people in Montana are experiencing for pests, disease, and abiotic issues in their home gardens. And I'm excited to be here. Thanks so much for inviting me.
Thank you. Pat, would you like this try? Go that way.
You bet. Good morning, everyone. I'm Pat Carr. I'm at the Central Ag Research Center, as Darren said, just outside of Moccasin. I got my degree at Montana State University many years ago. I was very fortunate to have the opportunity to come back, and we've been back in Montana about 5 years now, so it's great to be here today.
Thanks, Pat. Kevin.
Hi, yeah, I'm Kevin McPhee, pulse crop breeder located here in Bozeman. I've been directing the program here, a brand new program for 3 years, 3.5 years, I guess now. This is my 4th field season, making some good progress and pretty excited with what I'm seeing in the field this year. So as everybody is implied, it's unfortunate we won't be able to walk through the fields and take a look at things, but happy to describe what we've got going and happy to send pictures if somebody were interested in that. Thanks.
Thanks, Kevin. Perry.
Perry Miller. I'm a cropping system scientist here in Bozeman, and that means I get to work a lot with alternative crops and various soil management techniques, usually with some eye to sustainability. And I was smarter than the rest of these guys. I got here 22 years ago.
Thanks for being here so long, Perry. Welcome to the 20 Club. So we're going to start right out with Kevin. Kevin, this came in last meeting. I think you could add some to the dialogue. It came in from Choteau County. What's happening with the winter broadleaf crops, and when do you foresee that be impacting Montana's producers?
Okay. So the winter pulse crops, right now, as far as the breeding program is concerned, we are looking at the winter peas, thinking about winter lentils, but primarily now it's the winter peas that we're focused on. I made crosses the first year I was here, the first spring actually, in the greenhouse. The products from that, we actually have unreplicated or single plot nursery at Bozeman to look at that first material, and pretty excited with some of the material that's in there. We don't have any yield tests. Those particular lines have not been tested over the winter. So that's the plan for this fall. The intent was to plant them last year. Weather conditions didn't allow us to do that. So this fall, I'm hopeful to get those, depending on the amount of seed we harvest, at 2 to 3 locations and see what they'll do. What we have also done is sent out segregating populations to different research centers. I've had them at Havre for 2 years now. I had one the first year at Conrad, another nursery this year at Huntley. All 4 of those survived, all 4 locations. We were able to make selections in both years. There was good differential kill. So it gives me some confidence that we've been able to remove some of the weak lines, select more hardy lines, and those will be the first ones that have been tested, been proven to at least survive those conditions. We're increasing the seed from that, and we'll advance those into yield trial type nurseries that we can have some confidence that they'll survive. As far as impacting Montana agriculture, I think that's a little bit out in the future. I think I have good confidence at this point with what I'm looking at and the selections I've made, but there certainly has to be further testing. We have grants put together for that. A lot of interest from other entities that I'll be working with on that. So I think the future looks good. I know Perry's interested in having some different types of winter peas. He's seen some of what I have there by some of his plots. So I'm hopeful that we'll have something to look at in the near future.
Great, thank you, Kevin. Good thing, Zach, you're the first question I've got. Someone said they heard you talking about nutraceuticals in your berries. Mm-hmm. So could you please introduce yourself, explain to someone in Granite County what nutraceuticals and what the value is of the research you're working on at Western Ag, please?
Yeah, so my name is Zach Miller. I'm the superintendent of the MSU Western Ag Research Center, and we're the horticultural research center in our research center system. And we do a lot of work with both fruit and vegetable crops and a lot of other specialty crops, in addition to collaborating with folks like Kevin and other scientists to do variety evaluations. So nutraceuticals, it's a fancy word for just eating healthy foods. A lot of the buzz in the last 5 years or so has been on antioxidants, and so about that long ago we started a project looking at cold hardy fruits that have good antioxidant potential. So antioxidants are chemicals that are in lots of different foods that are healthy because they stop free radicals, which are particles in our bodies that damage DNA and cell membranes and lead to things like inflammatory disease and cancer. So we're growing over 50 different varieties of cold hardy fruits that include honeyberries or hascaps, elderberry, and aronia. And those three have at least 3 times the antioxidant capacity as blueberries, and also includes black currants, service berries, and a few other things.
And I can testify, if you get a chance to go to Western Ag Research Center's field day, you get to taste them all. You just can't taste the ones that are on the plants before you get to harvest them, right?
Yeah.
So it's a good field day to go to. Thanks, Zach. Abby, there's a question on end blossom rot. And I'm not a vegetable or tomato guy. I try to keep them off my plate, but could you talk a little bit about that? And is there variety differences that happen? And how can people prevent that?
Yeah, so blossom end rot is something that happens when there is a calcium deficiency in the plant and the fruit ends up showing the symptom of black spreading from the blossom end up towards the fruit. Lots of different plants are susceptible to this: tomatoes, peppers, summer squash, melons. But this doesn't mean that the calcium in the soil isn't there. It's usually as a result of inconsistent watering. So if you have a consistent watering schedule going and adequate water being provided to the plants, that should help this. But otherwise, it's pretty unpleasant and it does rot the fruit. So it ends up reducing your yield.
So is there a variety differences there? That was the other part of the question, sorry.
Yep. There are cultivars that are more resistant to this. Yeah. There are cultivars that are more resistant to this, but mostly it's management. So as long as you are consistently watering your plants on a regular interval, as opposed to just giving them water whenever you remember.
Perfect. Perry, this is coming in again, and it's very similar to the question we had when Chen Si was on. We hear that you've grown hemp and have some input. And how do you see industrial hemp fitting into Montana's rotations? Or how do you see it impacting Montana?
That's a good question. There's lots of questions about hemp right now. From a rotational perspective, myself, well, let me first say that Pat Carr, myself, and Chensi have been playing with hemp a little bit the last 3 years. And I've got a video online. You can check it out if you want. We just, there's not much for funding. There's not much support. So we're doing what we can in a sort of a limited basis. But it's kind of a tricky one to undress, because there's different market opportunities attached to it. There's oil opportunities, there's fiber, there's seed. And so, I mean, all of those might require different research focuses. From a rotational perspective, and I guess I was backing up. I've been doing my work in organic systems the last 3 years. And I have been generally impressed at how it has suppressed weeds, especially some of the taller varieties. There's some shorter varieties that don't do as good a job at suppressing weeds, but there's lots of claims being made about hemp. We've checked out rooting depth. There was some claims that it was a really deep rooting crop. Well, at least in our 1 year that we gathered data, that it was no deeper than spring wheat. So it would probably use water similar to spring wheat. I don't think there's any particular concern about volunteers from hemp the next year, but I guess we haven't seen that anyways. So somewhat competitive in an organic system. It's not a nitrogen fixer, so it's not going to do anything real positive then. It'll probably break up some disease cycles for cereal crops at least. But we just don't know much about the rotational aspect, to be honest.
Thank you, Perry. Pat, this in from Blaine County. Recently, they read that you're working on weed suppression in organic systems, specifically thistle. Can you comment a little bit about your objectives and where you are in that research project?
Yeah, sure, Darren. We are here at Montana State. Perry's involved in this project, as are several on campus. Fabian Manalid, Tim Seipel, Zach Miller is also involved. And really, we're targeting two perennial species, creeping or Canada thistle and field bindweed. And our goal is to really determine, can we move away from intensive tillage to control these two weeds? So we've got really a spectrum where we're looking at a very intensive tillage system, really done only at the research centers, because it would throw, I think, many people out of compliance by all the tillage that's being done. The systems where we're relying very little on tillage and a lot on things like animal grazing to try to suppress the weeds. Now we're in anywhere from 1 to the 2nd year of the study. As you can imagine, it was a bit of a challenge trying to establish treatments in fields that were infested with bindweed and Canada thistle. So in some cases we planted and then we retreated hastily and tried to reestablish other places. But it's still pretty early in the study. I think we are seeing some things that at least tell us there are differences in these various treatments. I think we're going to have some good information for farmers, not only in Montana, but in North Dakota and in Washington. Those are 2 other states that are involved. And I will say, of the research that I've been conducting over the years, this one has generated a tremendous amount of interest. I don't know how everyone's heard about it, but really nationally. So I know it's hard to believe, but we do not have a monopoly on bindweed and thistle. There are problems pretty much everywhere.
I have a follow-up question, if I may.
Only if it's not hard.
Okay, I don't think it's that hard. But I'm curious, are you planning on evaluating biological control for bindweed specifically, or thistle?
Yes, we are. Yeah, we are. That is part of the project. Jed Eberly is a microbiologist located here at Moxon. He's the other faculty person here, and so he's very involved in that project. Really, our focus to date, for the most part, has been on biological control of creeping thistle.
Okay.
Dave Sands at Montana State University, really working separately outside of this project, I think is looking a little bit more at bindweed.
Okay, great. Thank you.
Good follow-up. Zach, we're going to stay on the weeds. How in some of your systems, in your berry systems and rotational crops, are you impacting or evaluating weed suppression?
That's a broad question. So we're working with Pat and Perry on So at Western Ag Research Center, we're working with this USDA-funded perennial weed management in organic systems project to look at managing weeds in organic vegetable farms, and also in managing perennial weeds in organic vegetable farms, and also irrigated organic grain farms. What we've seen in our irrigated organic grains is, so we're a little bit farther ahead than the other projects since we started early. We already had a similar trial on the ground, and so we're now in our third year. And we've seen really good suppression from that intense tillage. We're tilling once or twice a month, every 3 weeks, basically, in those systems. But we've also seen the downside of that. Those soils and those plots were severely broken down, lost all their structure. It's still, almost all the way through the growing season, walking through those plots, it's still like walking on a beach. The soil is just broken apart. The spring wheat that's in there is not as vigorous. It's certainly lost a lot of water and nutrient holding capacity. But we've seen also great results by rotating alfalfa. So just a couple years of alfalfa, and we compared two different types of alfalfa there because organic growers were interested. We have a treatment where we've decertified and sprayed herbicides in the fall and the spring before we planted that alfalfa, and then just stayed in organic and just planted the alfalfa and kept the certification. And really, at least at this preliminary stage, we don't see any difference between those two. They both suppress the bindweed quite well. In our horticultural trials, we're looking at basically remediation or transition techniques for vegetable farmers that have a patch of thistle or bindweed. And there we're looking at intensive tillage as sort of our reference treatment, but also just cover cropping, the fall planted rye pea, and then doing some tillage to incorporate that cover crop, and also solarization with silage tarps, and then a combo between that cover crop and the solarization. And we just started that last year in collaboration with the horticultural farm at Flathead Valley Community College in Kalispell. They're also doing the same experiment. And thus far, it looks pretty, the tarping, the solarization looks pretty good. We just pulled them off yesterday, and it was amazingly clean. And yeah, so just stay tuned. We'll have more information about how that works. In our horticultural trials, we're really, our emphasis is to manage the weeds well. We're not looking at rotations there because these are plants that will be in the ground for a decade. But this is a good opportunity to emphasize how important that is when you're planting perennial fruit trees or berry crops. Managing those weeds in the first 3 or 4 years to get those plants established is critically important. It's much better to start out being very diligent and getting those plants big so they can be much more resilient and productive. If you slip up in the first few years, you can lose plants and really stump those plants for the rest of their lives. And so we rely on an integrated approach with a little bit of hand weeding, but mostly pre-emergent herbicides applied in the fall and early spring, and then some cleanup herbicides applied in the fall or early spring as well for getting those weeds that have already come up.
Perfect. Thanks, Zach. We're going to go to Fergus County for a two-part question, and I'm going to guess this is going to go to Perry and Kevin. I think definitely Kevin. When's the next lentil variety going to come out? And Perry, what are some of the work you've done on rolling lentils and recommendations behind that?
Do you want me to go first? So, rolling lentils is this near obligate practice that we've done for decades in lentils, and yet there's all these kind of myths out there amongst producers about what time of day to do it and what plant stage to do it or not do it, and when you start digging into the literature, there just isn't any. There's almost no research that's been done on it, and having done it now for 3 years, I can understand why. It's not easy research. But so we're about 3. We've got some partner sites at Havre and Moccasin, with Peggy Lamb currently at Havre and Pat Carr at Moccasin, where we're looking at different roll timings, 5 roll timings across a number of different seed densities in lentils. And we're in the second year of that. I actually had a preliminary year prior to that, where we looked at some data to get some of those timings nailed down. Last year, we didn't have a whole lot of differences. We had one significant difference here in Bozeman, but it was at a timing that I really, I was surprised to see it at that particular timing. So I want to do it again this year and make sure, see if there's something to it. But if we do somehow improve yields by rolling lentils at the right timing, even a small difference multiplied over a huge acreage could have a pretty significant impact. So it's just kind of research that was long overdue to get some real good solid data underpinning the timing of when to roll or when not to roll lentils.
Can you just get Kevin to make some taller lentils so you can just straight cut them and don't have to
Good
roll?
job. Good job. Being a cow guy, Perry, is this a disease response or what impacts the yield on rolling other than flattening them once?
The rocks in the combine.
Well, I got that part too.
So, I mean, we do actually have an opportunity to look at interaction with Fusarium on this particular project, although we're not seeing much on that angle. There is the fear that if you roll them at the wrong time, you might injure the plant and provide a vector and opportunity through those wound sites for maybe ascochyta or something like that to invade the plant. There's also sort of a physiological aspect. I mean, one of the old, and I'm going to call it a myth at this point because after getting into our third year, I feel like I can say that. We were told not to roll right at emergence because if you recovered that emerging plant tip somehow, that was going to keep it stuck underground, and we're just not seeing that. I mean, we're seeing the same emergence rates if we roll right at first emergence as opposed to right after seeding. And we're rolling all the way actually up to about the 10 node stage, which is just prior to flowering. And we're not even seeing much yield loss there. The first year we did it all the way to flowering. Yes, of course, we flattened things and you couldn't pick it up and it wasn't good. But so far it actually looks like it's a pretty broad window of when you can apply this technique. So.
Thank you.
Perry, is there anything with soil moisture conditions that other management considerations with rolling?
Yeah, so I mean, soil moisture definitely plays into it, right? Because if it's too wet, you may have a time in mind as a producer. Hey, I want to roll at this particular stage, whatever you become comfortable with. Well, it's too wet to go at that time. Now I've got a delay, and now I've got a delay. Matter of fact, I saw some lentils in Pat Carr's neighborhood a few years ago where the lentils were actually in full bloom by the time it had dried up enough, or at least the guy got around to thinking about rolling it. And what do you do at that point? So yeah, soil moisture matters. We had really good moisture at our site last year, so it really wasn't a limitation. And we actually have adjusted our roller to get the same kind of down pressure on a little 6-foot roller that you can get with a large commercial roller. We got to put extra rail weights on it and fill it up with water and make sure it's very heavy. But if the soil is very dry, like it was this year, we don't get as good a roll when it's dry. But I guess that's an important question that we really haven't tackled as much. We've had good moist soil at 3 of the timings that we've rolled this year. One time was pretty dry, and we didn't get as good a roll even with that heavy weight.
Perfect. I guess Kevin's on the hot seat for a new variety.
All right. So, you phrased the question, when would the next lentil variety be available? As far as the Montana breeding program here, the question is, when will the first one be available? Again, it's a young program here. We're in our 4th season, field season, and the first couple actually, were primarily just evaluating germplasm that I had access to. During that same time, again, just like with the other crops, we've been making crosses, advancing those to a stage where we're comfortable making selections. I kind of jumped the gun a little bit, moved the schedule forward in the pipeline a year ago. So last fall, with the populations I had, I made a single plant selection, single seeds actually went into the populations that we harvested in 2019. I sieved those for for specific characteristics, the seed size, shape, the color, other characteristics that we could see, and planted those in the greenhouse. And there were about, we'll say 225 as a rough number. But I planted in the greenhouse, harvested a very nice set of seed from those plants. And those are currently in for cereal programs, they referred to as head rows. I call them plant rows in the field. And I'm really quite pleased with them. Zach, you mentioned the plant height. That's one of the things, and the material that I'm looking at, some of it is taller than some of the others, and that also depends on which market class it is. And these lines that I have selected are they cover the range from small greens to large greens, and there's also some small reds, medium-sized reds in this set of single plants that are in the field. Pretty excited about that, at least to be at that stage. They're one cycle behind where the peas are in the program. So next year I'll have a large plot that I can evaluate yield and see it on a larger multi-row experiment, multi-row plot to see how they perform. But I'm pretty excited. Some of the seed that I picked is pretty interesting. Hopefully it fits the markets that I'm aware of. And as far as the next new variety, it's going to be, a couple, 3 years, probably longer than that. It's just going to take time to increase the seed, get it tested, have the appropriate number of yield trial sites. The data set has to have a specific number of locations. How we address and how we get that accomplished, I think we're going to have to be creative with all of the pulse crops in the program. But I'm pretty excited with where we're at right now. We're moving as fast as we can, a little more aggressive than I have been in the past with it, but I think it's going to pay off in the end.
Thanks, Kevin. Good update. Abby, I'm going to swing back to you and I'm going to ask a question. Can you talk about, seeing how you've been here for 1 month, can you talk about how you see your program developing and how you see you interacting with Extension and agents, and how are you going to handle the statewide deal and how you move forward?
Awesome. That's a great question. My background is in county extension offices in Michigan and Colorado, so I definitely understand what it's like to be a county agent with 10,000 responsibilities. So my programming is going to be directed, I'm hoping, a lot by the agents themselves. And so I'd like to get to know a lot of the county agents, what they're seeing in their localities and how I can best serve them, what I can do to make their jobs easier, and the types of programming they're interested in seeing, and the types of program formats that they might want to explore. And then my background is also in pollinator conservation, and that's a passion of mine. And so I'm interested in incorporating a lot of pollinator conservation horticulture strategies in a lot of what we're developing in terms of fact sheets, guides, materials, and looking into some potential research on that topic as well. So I'm hoping to mostly be available to agents and the public at large, and be able to help them with anything that they need horticulture related.
Great, thank you. I'm going to follow up real quick with the question. You mentioned pollinators. And in this, we had a robust discussion about cover crops and flowering plants and some of that earlier today. And how do you see you maybe using your skill set to help expand it into maybe just from horticulture into general production agricultures? Or is there a possibility to make that bridge or jump in with Western Ag Research Center and some of the work they're doing in their fruit?
I think there definitely is a possibility to make that bridge. I'm really looking forward to visiting the Western Research Station soon. But at the Hort Farm here on campus in Bozeman, there have been a lot of ideas about potential ground covers that can be used in conjunction with the fruit that they're growing. I know that a lot of ground covers like clover are very, very vital to pollinators, especially early in the season. And they can be a really good resource if done appropriately. And I know even home gardeners are interested in incorporating some sort of ground covers as part of their turf or replacing turf with them. So there are some great alternatives, and I'm looking forward to having these discussions, and I think there are opportunities to bridge these interests.
Outstanding.
We have an interesting new trial at the Western Ag Research Center in collaboration with David Weaver, looking at using cowpeas as a potential cover crop to support the parasites, the small wasps that attack the wheat stem sawfly. And it's the first time we've grown it. It's a really interesting crop. Cowpeas are black-eyed peas, or black-eyed peas are a variety of cowpea. Kind of like a soybean, but provides nectar on the plant surfaces that those tiny wasps that can control sawfly can get access to, because those small wasps are so small they can't really get into a lot of our legume flowers.
Yeah, that's awesome. Yeah, a lot of beneficial insects and natural enemies are present in the landscape. So being able to harness their natural abilities to control these pest populations is always going to be really a great way to beef up your landscape.
So I just wanted to have a quick follow-up too. So we've got a demo trial at our research farm where we have like 30 different crop entries in there. And they're all been, flowering stages the last, going on 2 weeks, but we've got one in there called Niger. I don't know, Zach, if you've ever grown Niger, but, it's got the pollinators, and they're mostly honeybees and bumblebees. And so I don't know if that, fits the, a wide enough spectrum, but they've got the pollinators, have got the choice of any plot they want along that suite. We've got mustards, we've got canolas, we've got vetches. I mean, anything they want. And boy, that Niger seed just seems to be, everything's in there. And so I wondered, Zach, if you'd had any experience with Niger, and it seems like there's, it's a specialty market, obviously, but it would be.
Yeah, what is it?
So it's actually it goes for bird feed. So it looks like sort of like a miniature safflower, I guess, multi-headed plant.
It's a sunflower family.
I should know that, but it has to be in the Asteraceae. Yeah, it has to be in that family. And anyways, pollinators just at least we've done this 3 years now, and every year I go through there, and I have to we're doing some growing degree day notes on it also, just trying to do comparative growth staging for all these different crops, and all the pollinators always seem to be in the Niger. So for whatever that's worth.
There are quite a few. Sorry, go ahead.
Nope.
I was going to say there are quite a few plants that are more attractive to pollinators based on maybe what they provide. So if the Niger has a higher nectar quantity or a better pollen protein content, I think you might have pollinators that are going to be other flowers. And then some pollinators are more specific. So honeybees have this behavior called flower fidelity, in which they're going to, if a few bees go to the Niger and it seems like a really good resource, the rest of the hive is also going to go and harness that resource before they move on to a different type of plant.
So being the person in the room that's been at Montana State 27 years, I can tell you, Perry, the last person I knew to grow that was Dave Witchman. And it was in one of his works when he was looking at expanding the bird seed world, when safflower and some of that was several years ago. So just FYI, if we want to go back to old data, check out Dave Witchman. So, but good dialogue. This is in from Ravalli County for Pat. I think they're cheating on you, Zach. Sorry. There seems to be a question of tillage versus no tillage in organic systems. And it seems like you're both using two different avenues. So Pat, how do you see expanding no-till and organic versus what Zach's doing down maybe not best management practice, but you got to do it to control it? I'm expanding from the initial question here, but I see there's a dichotomy essentially is what people are seeing. And so how do you see that expanding in organic systems?
Darren, I told you before we started, I only get an easy question. So.
Blame Ravalli County.
Well, I do think organic has a place, and I mean, to move beyond the study that I talked about earlier, Perry and I both, and this was back when I was still at North Dakota State University and Perry was over here at MSU, we were doing what a lot of researchers were doing and really looking at this organic no-till system that really grew out of the East. And originally, the origins are down in Brazil with conventional no-till. And what was relied on and is relied on heavily still are cover crops, where they're mechanically killed, but the mulch remains on the surface for weed suppression. And, you know, this was probably longer than I'd like to admit now, but I don't know, 12, 13 years ago, this was a really, really hot topic across the US into Canada. The Europeans, this was one of the few places where we actually got in before the Europeans got involved. And the bottom line was a few of us who didn't know any better tried continuous organic no-till. You know, think conventional no-till, we were trying to do it organically. And I think we all found the same thing. One, those who told us it couldn't be done were correct. And two, you had about a 4 or 5 year window is usually what would happen before the weeds would overwhelm you. If you think about weeds, you know, what group of weeds would just take care of the system, and it's perennials. You know, it's the ones we talked about earlier. It's bindweed or creeping thistle, but any perennial weed, once that became established, there really isn't a cover crop that you can grow in the mulch that you're going to create that's going to suppress that. And it's hard to keep them out. I mean, we all know that. I mean, the conventional farmer uses herbicides, or historically has. The organic farmer is going to use tillage. And, you know, I think we could talk, you know, at nauseum about this. So I think in terms of organic systems, that type of system, it can work in a place like Montana, but it's going to be a rotational no-till system. That system relies really heavily on, they call them a roller crimper, but it's basically a glorified roller, and then you've got some kind of blades and various configurations that you use to kill the cover crop. And you know, when we think about that and you think of the size of Montana farms, that's one challenge I think there is, you know, running a roller over all of your organic land to kill the cover crop. It's a lot easier to do if the roller's a little bit smaller, the land's fairly level. But it still does have a place, and that's where the animals come in too. You know, that was the other thing that we really brought into the picture. Perry did here in Montana, Martin Enns did up in Canada, is to bring in animals and strategically graze. And I think if you combine animals with cover crops, aggressive, you know, annual crops, you can probably no-till for a couple of years before you have to get out of that and strategically till, and then you can go back in. And really that, if you look at going to the study that I did talk about earlier, that's, we do have, you know, a couple of the systems in place that really mimic that. So I do think it has a place in Montana. I'm more convinced than ever that continuous organic no-till is something for the next generation to tackle. But we can at least reduce tillage in the state of Montana when growing crops organically. But we'll probably have to still rely on tillage at some point to take care of the perennial weed species that become established. Do you agree, Perry, or Zach? Or
yeah, just to jump in and summarize, and let me know if I get anything wrong here about the good work that you two did.
Okay, that's right.
There's also a fundamental constraint for dryland agriculture and no-till for using that cover crop system in Montana, because where those cover cropping systems are successful, you're growing about 4 tons of cover crop to lay down as that mulch to suppress those annual weeds. And in Montana and North Dakota and all of the Northern Great Plains, it's often too difficult to grow that much biomass in your cover to be able to suppress those weeds. And when you do, because we're in a water limited environment, you've used up the water, and so the crop you plant next isn't going to grow very well. And these systems will work fine in a 30-inch a year rainfall environment, but in Montana, because we're so, you know, it's semi-arid and a near desert in some dryland conditions, that kind of system just, there's some fundamental constraints to it.
Yeah, I would agree. Go ahead.
I would agree. And our site at Bozeman, actually, as you guys both know, was actually a wetter site than Montana. And so even there, when we had extra water to play with, we were fairly successful with 36 months, you know, a phase of no-till out of a 5-year rotation. But, you know, there's a reason that we're now studying perennial weeds at that site.
Right.
So I'm gonna add a quick question in. I know Zach's been associated with it, and maybe on the periphery, Pat and Perry, but there is a difference how livestock graze. And what was the differences on some of your effects when sheep were involved versus live beef cattle? Zach, on some of that, I think the sheep were far more effective.
You're the beef guy. Most of the work we've done has just been with sheep. We've done work with both sheep and poultry here at the Western Ag Research Center, and at Fort Ellis, where Perry does a lot of his work with this organic project. Sheep have been used exclusively, right, Perry?
That is correct. Yeah.
But I can say anecdotally, I can't say that word right now. In our trials with sheep, they really prefer bindweed. They'll go after it right away, and that backs up research that was done in the 40s and 50s. They don't avoid it. They seem to like it quite a bit, and they keep it browsed down. And so those perennial weeds aren't putting energy back into their root system and should be over time weaker.
Yeah, and just a quick on the beef end, I think we have a hard time terminating plants with beef just on their grazing style versus sheep that are able to get down there and get at it. Where if we're going with a high intensity grazing to target that, I think we have a more effective job using sheep. So, yeah.
Just to add one little thing, it is, just like with herbicides, if you're a conventional farmer, the sheep or the animals have to get on the right time. And Perry Brent, another MSU researcher who's involved in the project, I think didn't realize it, but he was commenting on that. He talked about the fact that, boy, they did a great job on the creeping thistle down in Bozeman and not near as good a job up here. And I think it had everything to do with the fact as to when the thistle was grazed in Bozeman versus up here as afterwards. So it's fun. It's really fun research to be involved with, because timing is really everything on a lot of these treatments that we have in place. You hit it at the right time. If the conditions are right, you'll get a fantastic control. If you hit it at just the wrong time, you miss that window, it's night and day.
Yeah. Well, good segue, Pat. Just a little plug for our 1 to 2 o'clock. Brent Rader, our newest sheep extension specialist in the state of Montana, will be on. We'll have Tim Seipel, and I forgot to pull my list up before I segued. Jessica Torian talking about forages, Pat Carr about annual forages, and Brent Rader and Sam Weifels on livestock end. So we'll be transitioning into some of that other dialogue, and we'll be able to pick that up. Kevin, I feel like people have been ignoring you a little bit. I haven't seen any questions come in, but can you just bring us up to speed and anything else pulses related that you want to do real quick?
Sure. So I guess I've already alluded and mentioned that I'm happy with where the program is at this point, taking the aggressive approach to move forward and making selections and getting the pipeline filled up with each of the various stages. The next year or two, we'll be seeing yield trials at some of the research centers around the state, which is pretty exciting to me. I'd made some selections last year on peas that, it was the first time had looked at them in a single row to get an idea of what their growth habit might be, how they perform. And I was cautiously optimistic and was mentioning that, what they looked like this year would kind of determine how good the selections were last year. And they look very good. I'm very happy with their growth. There's quite a range of variation from just above the knee-high plant type to above my waist. And they're still upright and that high today. That doesn't mean—
How tall are you, Kevin?
Well, we'll say that the waist high is about 34, 36 inches or something like that. So anyway, they're nice looking plots, and the yield is where it's at. We have to see what they're going to yield compared to the check that we have in there. The other thing that is really kind of taken a highlight and a quick step forward in the program is looking at end use. Protein is a huge focus point of the industry right now. How do we get more of it? How consistent can it be? That's something that we're looking at as well, making crosses specific for that. Some of those crosses admittedly are kind of a hope based on the data that's out there. We don't have a lot of data of a wide range of germplasm from the state to know what lines that are reported to be high in protein. Are they really high in protein in Montana? So that's where I'm headed with it, is increasing some of those prospects, I guess we'll call them, as parents, and then we'll evaluate those on a wider scale as time and resources allow. But I've already made some of those crosses in the hope that they'll be the right ones, and we can make selections as we go along. So the highlights are the pipelines getting filled for all three crops. Peas first, lentils a year behind, chickpeas a couple of years behind that. But across the whole set, we're looking at quality and not just what the seed looks like for the traditional markets, but the more recent markets of fractionation, understanding how much protein is there. And I think the next step beyond that is what's the functionality of the protein that's within the pea or within the legume? How is it used? And some of those questions are what we need to know on the research side, the scientific approach. We need to know what we're looking for. And once we know that, we can make steps toward those selections and use those technologies and techniques that are out there to determine which materials to keep and which ones to cross with.
Kevin, can I jump in really quick? You're talking a lot about end use quality and processing and harvest ease.
Yep.
What about pest resistance or other traits like end fixation? Because for a lot of growers, that's one of the big benefits of rotating into pulse crops is the additional fertility that they've got.
Sure. Yeah. So that's a great question as well. And another aspect that the nature of breeding programs is that we look at a lot of different things at the same time, trying to bring the best of everything into one or a few lines. On the nitrogen fixation side, working with Clayne Jones right now, looking at a set of varieties of peas and lentils to get an understanding of what are their relative efficiencies or abilities to fix nitrogen. And with the couple of years of data that we have, it looks like there are differences in variety or across varieties. We will use that information to make crosses, and as fortune would have it, one of the lines that seems to do really well, at least with a preliminary analysis, is a line that I really like to make crosses with. So I have some of that, those crosses made and making selections from those populations. The challenge with that is being able to move forward with early stage material where there isn't a lot of seed. How can we do those evaluations efficiently and ideally in a greenhouse setting so that we can look at individual plants, make the selections there, and then take the desired materials to the field. So that's a challenge we have, but at least we know that there is some difference among germplasm for the ability to fix that we can make use of. You mentioned diseases. That's another very large area that we're moving quite quickly. And actually, we have a nursery or an experiment that we're conducting in the greenhouse right now that we are evaluating parents that I've used in the pea breeding program for resistance to Fusarium oxysporum, so the Fusarium wilt. So we've run two sets of that material. The one is completed. The other one, we're about halfway through. We're able to use that technology or that approach, the methods in the greenhouse, confirmed some of the reactions that I knew for the material and learned about some of the more new and different lines that I have made crosses with. So we're going to continue that, not just for race 1, but race 2 will be next. So we can start pulling those genes together in the selections that we make. We have inoculum prepared through collaboration with Mary Burrows and one of her graduate students to look at Aphanomyces. So we're going to do that as well. That's the next on the docket. The Fusarium root rots, so Fusarium solani, Avanaceum, and there are several others that are involved. That's on the list as well of interest. We just don't have those particular tests in the greenhouse in place at the moment, but they're coming. So, if you look across the program, there's quite a lot of different objectives that we have to look at simultaneously, really, across diseases, agronomic performance, quality and end use, and a number of different things. So doing quite a lot and happy with what we've accomplished at this point.
And we want them all tomorrow, Kevin.
I realize that. That's why I'm coming up there tomorrow to harvest.
No, that's great. Hey, we're running out of time, everybody. I'm going to throw one quick question out for Zach and Abby because it's from Great Falls, but I'm going to direct them to your emails after I read the question. It says, what is the most difficult part of starting and eventually maintaining a small fruit orchard or horticultural vegetable enterprise? And this is out of Great Falls. So for this person, if you would, I'm going to give everybody an opportunity to say their emails. Why don't you redirect that to Abby and Zach as we move forward, because we're just running out of time and I have to get the next group in. So Abby, what's your email?
My email address is abia@montana.edu. So ABIYA.SAEED. Or they can call me at 994-6523.
Perfect. Thank you. Zach?
My email is dboss@montana.edu.
Nice. So
No,
everybody,
it's zachariah.miller@montana.edu.
Yep.
But you can find it and a lot more information on our website and a lot more of the other field day videos through the department's website. It's all set up and I hope you can take a look.
right. And I just got prompted by our admin, Sharon. She did remind me that everybody's contact information is on the virtual field day website. If you got here and got there, you'd be able to see it rather than have everybody go through the emails. I want to thank everybody and all of our panel today. It's been a great, robust discussion. Probably got a little different direction than we probably thought we were going to start with it today, but that's the fun part of doing live. It's been a great day. I want to thank you again. I would like to forward to do this again next year, possibly if it's great. And with that, have a great day. And for the public, we're going to dismiss our current cast of Gilligan's Island.
Just say characters.
Yeah, all right, characters of Gilligan's Island. And we'll let the next bunch in at 1 o'clock. We're going to take a 1 hour break for lunch. You don't have to turn down your YouTube. Just join us back at 1 o'clock. And again, thanks everybody. It's been a great day. Have a good one.
Yep.
Thank you.
Bye.
Bye-bye.
Good afternoon. Welcome to the Montana Agriculture Experiment Station's Montana State University virtual field days. I sure apologize that we have to come to you on YouTube Live. Field days are some of the best days I get to participate as department head of the research centers. I get to visit 7 different locations around the state and interact with the producers, sitting on wagons, listening to the research just like all of you, and I learn something every day. So it is unfortunate that the pandemic is not letting us come to you live in person, but we're going to do the best you can. Really quickly, this afternoon session, we're going to talk, we have 5 new candidates or contestants on the question and answer scenario. Dr. Jessica Torian from Northwestern Ag Research Center, Dr. Tim Seipel from Land Resources and Environmental Sciences, Dr. Sam Weifels from Animal and Range Sciences and the Research Centers, Dr. Pat Carr from Central Ag Research Center, and Mr. Brent Rader, who's a new sheep extension specialist at Montana State University. Welcome, everybody. Thanks for participating in such a great thing. I'll go around the room and give you a quick minute to introduce yourselves. Let's start with Sam.
Thanks, Darren. Well, as Darren mentioned, my name is Sam Weifels. I'm originally from Northeast Oregon, actually. So I did my undergraduate and master's education at Oregon State University. So my undergrad was in rangeland ecology and management and crop and soil science. My master's is in animal science, where we looked at different beef cattle stocking densities and how that affect grazing behavior and foraging efficiency and some performance attributes. I then took a break from my education after that and went and worked for the Natural Resources Conservation Service there in Oregon. So I got 5 years of working with producers and farm bill programs. Decided I hadn't had enough punishment with my education, so I went back to Montana State to pursue a PhD where I looked at grazing behavior and dormant season grazing for beef cattle under different supplementation regimes, where I measured a lot of supplement intake variables and supplementation practices, and then how that affect animal grazing distribution in the landscape.
Perfect. Thank you, Sam.
Yep.
Let's go to Tim in Bozeman.
I'm Tim Seipel. I'm a assistant research professor in the LRES and the cropland weed extension specialist for the Extension Service. My research program lately has been to really improve integrated weed management in our cropping systems in Montana, whether it's in organic systems or whether it's in conventional systems. Really trying to improve weed management because we have problems that come up. I know that Pat and Zach and those guys talked about Canada thistle or creeping thistle before being problems. And we have a lot of herbicide resistance in Montana that takes away some of our herbicide tools. So we've been trying to figure out how to integrate more continuous cropping systems, putting some cover crops in there, putting some forage crops in there, and figuring out how those impact the weeds and the other ecology of the system. So that's what I'll be talking mostly about.
Outstanding. Thanks for joining us, Tim. Brent, how about we go to you?
Well, thank you, Darren. I am the current sheep and wool specialist at Montana State University, based in the Animal and Range Sciences Department on campus there. I don't spend a lot of time in my office. I spend most of the time out in the field doing research and extension work. I'm also the supervisor of the Montana Wool Lab that's based in Bozeman, one of only 2 wool labs left in the United States. And in addition to that, I guess my background, I grew up on a multi-generational sheep, goat, cattle farming operation in Central Texas. Got my master's up here at MSU and worked for some different ranches around the state, and then spent about 15 years doing mostly prescriptive grazing research on rangeland around Montana, using mostly sheep, but some cattle and goats also. So,
thank you, Brent. Jessica.
Hi, good afternoon. This is Jessica. I am at the Northwestern Ag Research Center here. Been with MSU for just over 6 years here now. My expectation here is really doing a number of research that are related to both nutrient and moisture. I'm a field crop physiologist that's looking at the non-living impact of crop production, just like as I mentioned, nutrient and water are my focuses. Another one is just 3 years ago, I became a superintendent of the Northwestern Ag Research Center. So I dabbled in a number of things. Forage is one of them. Pat is very good at convincing me to be part of that area. Thank you, Pat.
You're welcome.
And so forage is also new to me, and I used my area of specialty in the nutrient side and water management side to be able to conduct forage. And so most of it is warm season crops, alfalfa. And as I said, I just dabbled in it for the past 3 years. So I'm honored to be in this conversation now. I feel like, why am I here? But I will try my best to be part of the team, I'm guessing.
You'll do great. Thanks, Jessica. Pat.
Hey, everyone. So as Darren mentioned, I'm Pat Carr. I'm at the Central Ag Research Center. Actually got my last degree at MSU, and then we were in North Dakota State for quite a number of years. While I was there, I was a cropping systems agronomist, as I am here. And some of that had to do with evaluating forages and particularly annual forages. I think many of those who are listening today, watching today, remember Dave Wichman. Dave was a longtime superintendent here at the center. Dave had a very active annual forage program, and that's really how I got to know Dave when I was in North Dakota. We would share information intermittently. So after he retired, I felt, and our advisory board certainly supported it, that we continue annual forage research here. It fits in well with my charge as looking at ways to diversify wheat-based cropping systems.
Thanks, Pat. I'm going to go back and give some people a time to add some questions in. And I'm going to go to Tim and maybe Brent to talk about it. We had a robust discussion on cover crops and dialogue on how that may impact weed suppression and the impacts of sheep versus cattle. So either one of you want to talk about weed suppression, either with or without livestock, and some recommendations on cover crops or grazing.
I can start talking about just the weed suppression side from cover crop side. So in 2018, 2019, we followed up on the project you guys started at the Northern Ag Research Center in Havre, where you had a wheat cover crop rotation in there. And we looked at some of these different mixtures of cover crops. And there's a video up in the soil. I made it into the soil section in there because we looked at soil health too. But what we found was, yeah, there's sometimes a pretty good ding after you've had cover crops in for a long period. Your wheat yields go down. But early season cover crops, lots of biomass, I know that was mentioned before, really suppressed weeds. They suppressed the amaranths, the pigweeds, the kochias. They did a good job of suppressing weeds in there. The later season, warm season crops like millet, those things didn't kind of put on biomass early enough. So from a weed science perspective, early season cover crops with lots of biomass is how you suppress weeds.
Great. Thank you, Tim. Brent?
I think one of the major differences between grazing weeds using livestock and rangeland and a rangeland setting and a cropping setting is that one of the things we learned early on after quite a bit of experimentation, and we've been grazing rangeland weeds since Dr. Olson really started it with spurge back in the late 80s, actually at Bozeman, was we kind of learned in a rangeland system, you really need to focus on your desirable. So you want to impact the weeds as much as you can. Some of the previous discussion before lunch talked about timing, and that is one of the things that plays a big role. In a cropping system, though, you're not specifically worried about and a lot of times in a cover cropping system, you're trying to terminate that cover crop. And so you're not as worried as you are in a rangeland system with protecting those desirable species. So in a rangeland setting, say you're grazing knapweed, we know from research that you need to go in after about the 4th of July. Knapweed isn't extremely palatable to either sheep or cattle. We basically just want to remove the flowers off of the top of it. If you try and graze it too hard, they impact, say, your rough fescue or your blue bunch wheatgrass too much. And so in a rangeland setting, we really want to focus on the desirable species out there. As Darren talked in some of the discussion before lunch, there's also a big difference between class and species of livestock. So goats are very selective eaters. They basically go in and remove very specific parts of the target weed that you're after. Hit browse a lot heavier, the browse and forb species. Sheep are more of a generalist eater. They will use both browse, forbs, and grasses. And in cattle, because of the basically using their tongue to kind of pull when they eat, they tend to use mostly grass species. One interesting thing that we did have is we were looking at the impact of cattle grazing during Cyphloleonis emergence. And Cyphloleonis is a large beetle that basically eats the roots out of knapweed, is fairly well established in western Montana. One of the interesting things we were seeing with that study versus sheep is that we were finding a lot of knapweed plants that were broken off. Sheep basically were going in, taking the buds off of the knapweed plants. The cattle were using their tongue. They were wrapping around those knapweed plants. And because the Cyphloleonis had weakened the root structure, they were basically pulling those knapweed plants up by the roots and breaking them off. So just kind of a general overview of prescriptive grazing differences between cover crop and a rangeland setting.
Great, thank you guys. Pat, this is coming in from Terry. I think that's Prairie County, if I'm doing right. Can you give us some thoughts on reducing nitrates in your annual forages, on when to cut, and any recommendations on current annual forages you've had good yields on?
Okay, sure. I think as a general rule, the later or the longer you delay cutting an annual forage, the less chance there is of nitrate problems. You know, conversely, the earlier, the greater the chance. In terms of species, and I think if you would move over into North Dakota, you'd see quite a bit more oat being grown than barley, like in Montana of the spring types. And you know, oat of the cool season annual forages tends to be most prone to nitrate, excessive levels of nitrate building up. So, you know, that is one reason I think why you see more barley being grown in the state. And I know when Dennis Cash was here and Dave, they weren't real supportive of a lot of oat being grown for that reason. Now we are growing more oat in our annual forage trial, and oat can yield fairly well, but again, it's just more susceptible to nitrate poisoning. In terms of species, you know, I'm following Dave's lead, although there's a lot of data to support it, and also the programs that we have. Phil Bruckner has been actively breeding for forage type winter wheat varieties. So Willow Creek, I think, is one that a lot of Montana farmers who do grow an annual forage are familiar with. You know, it's a winter wheat variety. Ray is a more recent release out of Phil's program, and you know, Ray is also really was bred for forager hay production. Jamie Sherman is our barley breeder, and Jamie is now actively selecting for not only good malt types, but also barley that can be grown for forage. So I would anticipate there being some pretty good barley choices, modern choices to maybe replace some of the older ones that Montana farmers and ranchers have been growing. Really old ones like Horsford, although I don't think too many grow that anymore, but Haybet, some of these other ones. I think Jamie's going to have some newer barleys that are going to be very, very competitive. And one other thing, I know I'm going a little bit longer. One thing I like about comparing Ray and Willow Creek, there's a common perception that a taller annual forage is going to yield more than a shorter annual forage. And data in Montana, and Ray and Willow Creek are a pretty good example of that, really demonstrate that is not always the case. So you can't really go with height as being a selection tool always. Ray here at the Central Ag Research Center in general has yielded at least as much, and in many cases more dry matter than Willow Creek when harvested at the same growth stage.
Outstanding. Thank you, Pat. Versus some very taller trits that are out there in the world tend to get a little more stem, a little little less stemmy, more tillers on the Willow Creek. Is that what you're thinking?
Yeah, yeah, the triticales are pretty tall. You know, Dave continues to select for them. I think in general, they do yield pretty well. I mean, if you compare many of the winter triticales to the winter wheats, the triticales in general are going to yield a little bit more. Where the winter wheats win typically is quality, and that's not surprising if you know how triticale was developed and why. So, but I think, you know, a good farmer can, and a good rancher can select varieties. We can do a lot with management. Again, like I said, you know, this is one area where as a manager, you have a lot of control. Longer you delay to a point, the higher the dry matter yield's going to be in general, but you're going to sacrifice quality. So you get to decide what you want to do, not only in selecting the crop type, whether it's a triticale or a winter wheat or a spring barley or spring triticale, which we've got, but also when you want to harvest them. And that's oftentimes what it ends up being, is some kind of compromise. You can kind of live with a certain amount of tonnage, but you really want the quality, or vice versa.
In regards to weed suppression, we did some trials at Moccasin as part of a project we called Many Little Hammers. And we were looking to manage wild oat, and we were looking to manage kochia.
Now, don't promote the taller varieties.
Yeah, and we had when we had the winter triticale in there, and it had to be harvested a little bit earlier than we would have liked for getting weed suppression out of there. The spring barley, spring pea mixture, you could leave it a little longer, then cut off your kochia or wild oat that was in your field before any seed was viable, and you got pretty good reduction in seed production. Combine that with another method for terminating it then, and you got actually really nice weed suppression out of it.
So Tim and Pat, are you saying that using cover crops to control specific weeds, you may end up with a situation like we do in livestock, where we really target the class and species of livestock that's going to impact the target weed that you're trying to impact? So you might, you know, if it's a winter annual versus a summer annual versus a perennial, you might eventually come up with some recommendations on, well, we need to use this type of cover crop to specifically try and take this type of weed out. Maybe eventually that research will get there.
Yeah, I think absolutely. That's what I've been trying to start to pick at, is what cover crop can we really use to sort of hammer at kochia and be most competitive against it? Wild oat too.
Yeah, no, that's right, Brent, for sure. And I think there's some research that's already been done that supports that. And I think too, when we talk about cover crops, you know, in this context, we really need to talk about dual use crops, because they're really cover, but also forage. You know, we've got, they serve two important functions.
It's really critical, in my opinion, when we talk about cover crops, is to first establish your goal of what your cover crop is. If we're just going to throw a cover crop in the ground, it doesn't do us any good. If we're going to throw a cover crop in the ground that is going to be used for grazing or weed suppression, or I want to graze it in the fall with my calves, those are three different types of cover crops we should be planting and harvesting. So I think as we make recommendations as experts in the field or university professionals, we need to be focusing on our producers to stop. Number one, what's your goal? How are you going to use it? And then design the cover crop behind that. So I think that's one of my big things. So I appreciate you all bringing that up. Sam, we have a question from Phillips County about how protein supplementation or energy supplementation impacts grazing in late fall or winter grazing. Do you have a question on that, or answer that question?
Sure. So there's kind of a couple questions within that question. So most of the stuff that I've done is, or I guess the first part of that question that we can talk about real quick is a protein supplement versus an energy supplement. So a lot of times when you're talking about an energy supplement, you're talking about supplementing these cattle with like a grain source or a concentrate, mostly a highly digestible carbohydrate. Protein supplementation is exactly what it sounds like, and that's where you're supplementing with a protein specific. When you're talking about late grazing or late season grazing, typically forages are deficient in protein, so you end up with getting a little bit higher bang for your buck, if you will, with your cattle's grazing supplementing with a protein versus a energy source. So for instance, if you supplement with an energy source, you're going to end up, you can actually depress how much your cow will eat overall, where protein will actually help improve some of that. And so some of the research that we've looked at with protein supplementation and grazing behavior, we found that if you're going to do some hand feeding cake, especially daily, you might actually limit that animal, how much time that animal is going to graze per day. And you might limit its distribution, especially if you're going to be feeding that cake in the same location every day. On the flip side of that, if it's a drought year and you're pretty low on your forage availability, that cake might actually provide some additional fiber and stuff to help those cattle. The self-fed protein, loose protein and stuff like that seems to have your cows seem to distribute a little bit better across the landscape, graze a little bit longer, and so that can actually play a factor as well.
Great, thanks, Sam.
Yep.
You kind of mentioned beef cattle. Brent, is there anything different about sheep you want to comment about that question?
Well, MSU did quite a bit of sheep research, winter supplementation starting in the 50s when they acquired the Red Bluff research facility. And it culminated probably in the 90s with Dr. Cotton, Dr. Thomas summarizing a lot of that stuff. I'm sure, Darren, you remember Dr. Verl Thomas well. And they summarized all that research, and a lot of what it found on the sheep side of it was in most winters in Montana, you needed, on average, you could supplement about 33 grams of crude protein, which comes out to, I think, about half a pound of a 16% cake per head per day. A lot of times I kind of recommend going to the every other day feeding. That just puts more supplement out there. If you've got some older ewes or some younger yearling ewes mixed into that group, they're not having to fight as hard to get a bite of that protein. The last couple of winters, I would say we've been pretty deficient nutrient-wise, at least up in the northern Great Plains area. The weather, I'm sure you are well aware of, Darren and Havre, the last couple of winters have been pretty ugly. We've set all-time snow records in Choteau 2 of the last 3 years, and it's kind of showed up in our lamb crops. And so I've been recommending to everybody, I've got to write an article for a magazine that's due next week on testing hay and feeding hay, because I think we've been pretty remiss on that for the last couple of years. But in general, I agree with a lot of what Sam said on that research that's out there.
Perfect. I'm going to put a plug in. Good transition, Brent. I think that's the cheapest bill I pay every year is my forage sampling and hay sampling and tests. I can't feed it properly if I don't have those tests. And these are fields I've known for 25 years, but I can dial it in a lot better. So it's the cheapest thing I pay for is a hay test. And so great. Jessica, this is from Sanders County. They understand that you do a lot of alfalfa research. Can you talk to them about the highest, and they worded it different, so I'm going to take some liberty on the question. Can you give us the top things you've established for increasing yield and quality in your alfalfa trials at Northwestern Ag Research Center?
Sure. So thank you for that question. This has been maybe the fourth year that we've been doing alfalfa. Primarily, the reason being was, there's data out there that our fall is extending a little bit. It's warming up a bit. And so as a researcher, we want to adapt, right? So we want to make sure that we take advantage of the length of the lengthier season in the fall. And so initially we were looking at different genetics of alfalfa. In fact, we planted fall dormancy 2, fall dormancy 3, and dormancy 6. And recently we've even planted fall dormancy number 7. And these are not your typical management toolbox in alfalfa. This is something that is outside of that. Usually we plant, 2 to 4 in Montana. I'm not sure if someone is growing fall dormancy number 5. So as the numbers increasing, you have less dormant alfalfa, and then you have more dormant alfalfa. So it is very surprising, in a rain-fed environment, all of these dormancy have equal yield levels. But as soon as you provide irrigation, fall dormancy number 6 and 7 are would just be yielding really high. And these are the varieties that's Cisco 2 and Magna for 7. With a caveat though that there's fall dormancy number 6 that we tested that didn't perform very well. And in fact, it tends to be kind of somewhere down in the bottom of the rank for irrigated environment. And I think because high just alfalfa is bred for something else, for quality purposes more so than the yield, I believe. All the breeders tend to make sure that yields and quality are somewhat similar, but that's the only thing that we observe. If it's a high just type of fall dormancy number 6, it tends to not compete with the other, like Cisco 2 and Magna, which is 7. And you know, we grow Cisco 2 for 3 years now, and it's still continuously the achiever among those varieties in irrigated environment. And Magna, which is fall dormancy number 7, is continuing to yield 2 on year 2 of establishment. So we played around with, you know, nutrients and moisture regimes just so that we cover all our grounds in terms of available nutrients and moisture in alfalfa. But yeah, we are surprised. Fall dormancy 6 and 7 are continuously showing, you know, high yield in a high yielding environment like Northwestern. It's pretty good, better than other genetics that we've used in an irrigated environment.
Perfect. Thank you, Jessica. Tim, this one's in from Rudyard. They're in the hotbed of herbicide-resistant weeds, as you probably know, in that triangle area. And the question is that they're a traditional crop fallow winter wheat environment. Are you saying the integration of cover crops is going to eliminate his herbicide weeds? Or if he has escapes, won't that propagate the problem with the cover crops?
Well, this is what I say, and I was up in Phillips Valley, came over into Blaine County last week, and I was out looking a number of fields, talking to a number of producers, looking at some different things. I saw the most weed escapes in fallow, whether that was prickly lettuce or kochia. Those were the two big ones that I really saw. And then if you looked in areas where you had we looked at some test plots in Loring, for example. We were up around Loring, and then I was down in Phillips County. And when they had a hay barley planted around the test plots and cut them off, you looked in there and that kochia was small. It had just been cut off, but it was 2-3 inch kochia. You looked in the areas where there were skips in the middle of that because the drill ran out of seed. Big kochia, 8 inches, 12 inches tall in a big ball. Now, if you cut a hay barley off like that and you come back in and you apply some sort of burn down herbicide that's effective, that herbicide on the smaller weed is going to be much more effective than it is on a larger, big kochia. And I saw a lot of half burned down kochias. Is it going to solve all our herbicide resistant issues? No. But adding in some sort of forage crop in there or some cover crop can really reduce the size of that kochia and give our herbicide tools that are still doing a good job on kochia more power to kill those small plants.
Thanks, Tim. And just a little bit of tag on with that question, seeing as how we've got 8 years of work here at Northern Ag Research Center for complete winter wheat cover crop or spring wheat cover crop trials. And we have to admit there is a drag on the wheat yield the next year, depending on strategic rains. If we had strategic rains at the right time, especially the winter wheat was able to compensate for not having that stored moisture from the previous crop. But if we were able to integrate livestock into that grazing component, it looked like it would be a little more profitable mechanism than a crop fallow, even with a wheat drag. And just so people are listening, Anton Beckerman and George Haynes are trying to work through that full economic analysis, so we'll have better numbers for that on you. So appreciate that, Tim. Yep. Pat, there's a question about fertilization and annual crops. Do you have any comments on where they should be going with that?
Well, you know, generally you're going to apply less fertilizer when you're growing that same crop for forage than you would for grain. And you still should soil test, but as a kind of a general rule, it might be like 2/3. You know, you can back off 25, maybe even 30% of what you would typically apply in terms of nitrogen. So that is an advantage of growing a forage. The plant still plants, so it still needs the nutrients that it's going to need to maximize dry matter production, but it doesn't need as much. And you've got to be more careful because excess nitrogen is an environment you don't want if you don't want to run into nitrate problems. So it's a little trickier, but I think in general, a good rule to follow is always soil test if you can, but then back off the nitrogen rate. Still needs phosphorus, still needs the other nutrients. You need soil test to get some idea of where you're at.
Perfect.
Just to add to Pat, that's a very good question that a lot of producers would ask, especially with, on the quality side. There's a number of hobby horse owners in the valley and even smaller ruminants. And so it becomes, the choice of forages in terms of quality is becoming really specific. And so we were funded by the Montana Fertilizer Advisory Committee this year, and we're going to conduct it in 2 years. And we conducted studies of using teff and Sudan grass, different sources of this species. And we put on like no application of nitrogen, for instance, and then a total of 75 pounds, from the residual and what you're applying. And then we increase it by 25 points, so 75, 100, 125, and 150, just so that we could document and trace, nitrate and quality and yield over time and have a better grasp of our recommendation in terms of nitrogen for these annual forages. But Pat is very much correct. We don't want to over apply nitrogen on forages. I think if you have a low input system there, forage is better option in my mind.
Perfect. Thanks, Pat. Thanks, Jessica.
Correct. Did you hear that?
Yeah, I got it. Check.
One thing I did want to add too, and it's somewhat unique to Central Montana. I never dealt with this until I moved here, but I think many farmers and ranchers know this. But around the research center in Central Montana, we do have a lot of sulfur deficient soils, and it's dramatic. And Dave Wichman did, I think, some research that really demonstrated this. But that's one place where a soil test really probably isn't near as accurate as really previous crop performance, and it can be very dramatic. It looks a lot like nitrogen deficiency, where you look for the differences where that deficiency is occurring. Nitrogen moves pretty readily in a plant, sulfur doesn't. So you're going to tend to see nitrogen deficiency in older material, whereas with sulfur, you'll see it in younger material. But the only reason I bring that up is, it can be dramatic. It can be the same impact on yield as, for those of you who are familiar with growing, pick your crop, wheat or barley, where you don't apply any N. And one crop that does impact is the one that Jessica's talking about a lot. It applies as alfalfa. At the research center where we have these low sulfur soils, if we don't apply sulfur, the alfalfa simply doesn't grow. It's dramatic. So do be aware of that with soil testing. It's really not going to be a good indicator of sulfur or sulfur deficiency. And canola growers know this, but if you don't have much experience, and you see a crop not performing very well, a tissue analysis will tell you if you've got a sulfur problem or not.
Perfect. Thanks, Pat. I think this one's going to be for Brent and Sam. This is from Madison County. They're looking to get into grazing cover crops in the spring and the fall. What kind of precautions should they be worried about? I'm assuming we can go to 2 different species here, whichever guys you want to take about, and thoughts. And in my mind, when I read the question was Pat covered nitrates, but maybe prussic acid and composition of maybe, some other type of species. So you guys want to touch base on that, please?
Sure. Go ahead, Sam. Age before beauty.
All right. Yeah. One of the big things that I think you got to be aware of, and I've been working with Darren on some of this with their cover crop program that they've been doing, I think, for the last 10 years, and trying to use some of this for forage source for beef cattle. When you're picking some of these cover crops and what you're going to graze with them, there's some tricks. And so one, if you're going to have any like annuals in there, nitrates, I would guess, would probably be the biggest problem that you want to pay attention to. One of the other things I've kind of been looking into and running to is this concept of using C3 or C4, a forage base. So warm season or cool season forages, especially in a dry land, although the C4 seems like they hold quality longer in the season. So if you're going to be grazing early summer, midsummer, the quality looks really nice. But if this is a dry land situation, I think you might be a little bit disappointed with the production, just because there's not as many growing degree days for those C4 plants to put the production. So you end up with this nice high quality. There's just not a whole lot of production there. And so you don't actually have a big forage base for those animals to eat. And then I'll defer to Brent for the rest.
Well, some of it, as you talked about, Darren, there's a couple of different reasons you put cover crops in. I live in the heart of the Greenfields Irrigation District, and this has been the malt barley capital of the world. Generally, our irrigation water runs out sometime in mid-August. One of the nice things about having the addition of a lot of people going to center pivots is, if they get that barley in early enough or cut a winter wheat crop, they can go in, blow some turnips or radishes on, get one quick turn with their pivot and get some good fall grazing. And so, as Darren said, you really have to figure out, why am I putting this cover crop in? Some of the specific differences between sheep and cattle, we generally don't tend to see as much of an impact with nitrates with either sheep or goats as we do with cattle. They tend to process those nitrates probably a little better than cattle do, within reason. Prussic acid obviously is a big issue, especially with Sudan grass. Millet does not generally have a prussic acid problem. The other issue you've really got to watch with sheep is, I think we've kind of gotten away from a buckwheat cover crop just because of the export market, but buckwheat does have a chemical in it that causes a photosynthesis reaction in whiteface sheep, and basically their heads swell up and they get a pretty nasty sunburn. And so those are probably the big issues out there that I see. You could run into with those perennial type or biennial type, say sweet clover, or some type of really obscure annual or alfalfa. I see some of those varieties out there that I really don't even know what they are. You could end up with a bloat issue there if you're not careful with it. But for the most part, if you stay away from the buckwheat and kind of monitor I'm probably getting 2 calls a week right now on whether or not people can turn sheep in on Sudan grass. And so,
yeah. I think of nitrates as an anti-nutritive compound, and it's something we have a hard time managing. I think of Sudan grass or Sudan grass, sorghum's more of a management thing. It's something, if we're managing it right, we can absorb and make that work and graze it. One of the problems I see in our trials in cover crops and late fall grazing is we may stockpile our cover crops in a windrow to be grazed later, and we get ready to graze them, and that sorghum Sudan grass is now 8 or 10 inches regrowth, and that's really the wrong time to be putting animals out on there, right after a big traumatic offense, whether it's cutting, frost, or whatever. So it's more of a management thing. It takes a whole lot more. You have to be dialed in when you're turning cattle out, because I'll tell you, the first time I heard of someone turn out on cover crops, and it was over 10 years ago, he said, I'm turning out 3 pot loads of bulls on this crop that he put in the ground. I don't know what it is, but I'm turning them out. And I said, well, 3 pot loads of bulls, let's stop and figure out, first of all, what's in the field. That's quite a bit of investment in livestock. So we have to think about that. So good comments, fellas. Thanks. Brent, the next question came in real quickly. How was the wool clip this year, and how do you see it coming out next year with the current status of the markets?
well, for anybody, a quick overview of anybody that's not invested in the wool business, we we're coming off of historic highs in the wool market. We had growers in 2018 and early 2019 that were selling wool for $10,000 a ton. It was probably the highest agricultural commodity produced in Montana on a per ton basis. When COVID hit last fall, basically they shut all the Chinese mills down. Now with basically everybody attending business meetings via Zoom and YouTube online, nobody really has to get dressed up anymore. And so the market for those high-end wool business attire fabrics have dried up. And so basically, other than some military contracts here in the US, our domestic wool market is dried up. We were hoping that we were going to be coming out of the COVID issue, moving into the third and fourth quarter here in the United States. Hopefully by Christmas, we're going to be seeing a major improvement. Basically the domestic buying is shut down on wool. And so we're just kind of in a wait and see. There's some good federal programs out there through the Farm Service Agency that we've been encouraging everybody to take advantage of to try and cash flow into the next year. The other issue real briefly is we just lost one of the major packing houses. Mountain States Lamb Co-op filed for Chapter 11. JBS acquired that packing house in Greeley back from them. And so that was 1/5 of the lamb harvest capacity in the United States, and probably well over half of the lambs in the northern Great Plains were harvested through that facility. And so it's going to have a major impact on the lamb market moving forward. I wish I had better news for people. Like 2020, I tell you, December of 2019, I was telling everybody 2020 is going to be the most phenomenal year in the lamb and wool industry we've ever had. And yeah, it's has not turned out that way.
So funny you say that, because someone left. Can everybody see my mug, right? Everybody know whose that is, right? Wile E. Coyote. I think 2020 was brought to you by the Acme Corporation.
Yeah.
So this is a quick question I coming in, and it didn't say where it's from. Maybe Pat and Jessica, I think, can do it, but maybe it was spurred by some of Sam's comments about warm season annuals and the impacts in Montana and how you see that happening. So I don't know who wants to take a whack at it first, Jessica or Pat, on warm season forages.
I'll whack.
All right.
I'll keep my comment, short. I guess really as just an add-on to what Sam was talking about earlier. We have found some potential for warm season forages. We did a study here at Central Ag, and just in terms of dry matter production, some of them did compare pretty favorably with some of the cool season annuals. Now, this was all spring seeded stuff. We didn't have any winter annuals in there, which may be a different story. But in terms of dry matter production, they did perform relatively well, which is surprising. But again, our soils here are kind of unusual. Now, as a major caveat, we did not look at quality at all. Prussic acid, I just pretty much ignored that. So, can't comment on that. But in terms of just dry matter production, I mean, it's not true across the board, but there were some warm season annuals that did hold their own. Okay, Jessica, now tell them I'm wrong.
You are always correct, as I said.
Oh God, don't say that.
So in our area here, we tried last year a number of things, cool season and warm season too, but we planted them around, in spring too, for both of them. We had teff and Sudan grass were in the highest in that. We only irrigated it maybe a couple of times just to have a better establishment at the vegetative stage. So our yields are close to 3 to over 3 actually in Sudan grass and teff on just, I remember 1.5 cutting, I think. And so I think here with our nitrogen study on Sudan grass and teff, I mean, they're just extremely happy, only because I think, as I said, we have good rain amount this year also, and it's a lot colder in the spring. But mind you, the corn silage last year, it was in the range of 25 to 28 tons per acre. So, I mean, I think that's a nice number to have.
Yeah, new modern genetics have sure helped that a little bit, you know, on the corn varieties, and we've played with teff here at Northern Ag. And the old days without the seed coat, it was kind of miserable to get good stands and good production. So I think that seed coat's helping that teff, and we had pretty good luck here also on a warm season. So we're down to about 5 or 6 minutes left to go. So I'm going to go around the room and have comments from each one of you as we wrap up today. And Pat's already waving goodbye, or do you want to start?
I've got a question.
Okay, Pat.
The question with the animal people, and also I guess Tim, this is directed at you. You talked about it a little bit earlier. So, you know, there's been a lot of interest among cover crops and cover forage crops and these multi-species combinations. From an animal perspective, are there any advantages to growing, you know, a 7 or 8 species mixture versus growing a monoculture?
I'd take a stab. I think a lot of it goes back to Darren, what you brought up. It's what is the ultimate goal? You know, I mean, it's yeah, sometimes animals do better in a multi-species environment because they have more selection, and so they can have a little bit of preference in what they want. But if the goal is to terminate that cover crop or to target a specific weed, that cover crop mix, I've read some of the research on that, and I don't know. I think the research is still there's been no decisions made, I would say, hard and fast on whether or not a mix is more effective than a targeted single species. It seems like from what I've read on it, and so I think a lot of it just goes back to what Darren said. What's your ultimate goal? Then if you know what species you're putting out there, then you can match your desire. If you want to terminate that crop, now do I bring in pairs? Do I bring in heifers? Do I bring in yearling ewes? Do I bring in goats to terminate that deal? We are getting a lot of requests, as you said, Pat. This research that you're conducting, and Tim and everybody else and Perry down there, word of mouth is really spreading it. I talk to a lot of sheep producers around the state and goat producers also. They're getting a lot of requests to come in and graze these cover crops off. And everybody's referring back to the research that MSU is conducting, and so I think there is a lot of interest out there, and I think we're fairly timely in that research at this time. So,
great. Tim, anything to add?
I think from a weed suppression standpoint, the more biomass you put in there, whether it's a 1 or 2 species mixture, you want the biomass in there. If you put the warm season things in there, they come on a little too late for weed suppression. You want to have cover on the ground and you want it to be fast. How many species do you put in there? I like to say, you know, you want something, a mustard, a grass, and maybe a legume. I don't think you need to get very complicated from my perspective on weed suppression. I will say this, we had those funny chambers out at Northern Ag, the climate chambers for a couple years. People asked us a lot about them, where it warmed things up. One of the interesting things we saw was with the oat, vetch, mustard, sort of brassica turnip mix, when you made it warmer and drier, the oat mass went down and the brassica compensated for it. So sometimes there's some unforeseen things that happen in there when you think about having your cover crop mix. But it goes back to your goals. If you're looking for soil health, if you're looking for forage quality, if you're looking for weed suppression, you really have to define your goal straight in the beginning.
Yep. Yeah, and it looks like we must have dropped Sam on the Zoom call, so I'll jump in real quick. We only got about 2 minutes left. Beef cattle producers have very tiny margins, so I'll speak on that. Biomass is king. Give me as much as I possibly can get. Just because it's that tight. I mean, if we get a better weed suppression than not, that's understandable. I would say the other thing, Tim, I think one thing that might help is if you're willing to do 2 burn down steps, one very early, get rid of those winter annuals that are coming in your crops, then burn it down right before you put these warm season crops in. Yeah. And don't just put a single row or a single corn crop or a low density thing. I mean, personally, I have nothing against sunflowers, but I don't think it has a business in a cover crop because it costs expensive, it's fuzzy, cattle don't like to eat it, and it doesn't do anything for weed suppression or biomass. So why not put a millet or a sorghum Sudan grasses that's going to canopy closure, get massive, get great, and there's better oil seeds like a forage canola that we can put in there that'll do a lot better job, because then push those warm seasons off. We can either windrow and stockpile and graze it late fall, because we know from previous research that those windrows are going to retain that high quality feed a lot better than standing forages, because we're going to lose leaves in that. It takes some training by your livestock to be able to do that type of windrow grazing late in winter or after it snows. The first year we tried that on our pivots here, like Brent was describing, we threw a bunch of weanling calves out with some yearlings, and they looked at it like, so there's big lumps in the field underneath snow. And finally, our operations manager had a great idea. He took our rake out there, raked 2 windrows together, and the cattle got it and realized that's where the forage was, and they just devoured it. So there's a learning phase. I think there's a really definite phase. I agree with Pat on warm season covers, depending on how much moisture you want to use and when you're going to graze it. So good question, Pat. Thank you. With that, we're going to have to wrap it up so I can get the next bunch in here. I want to make it out to the public that everybody's emails that was on here, and I apologize, Sam Weifels got dropped off, but he is available via email if you have any questions about grazing distribution. Tim, Brent, Pat, and Jessica, thanks for having us today. Their emails are also on the MSU Field Day webpage, or you can Google them on montana.edu, and they'll be happy to answer any questions. And once again, thanks for joining us this afternoon.
Thank you.
Thank you.
Thanks, everybody. So for the general public out here, we'll dismiss this group of experts, and we'll bring our next one in about 10 minutes, and we'll be starting at 2 o'clock with entomology and most of our breeders. It's kind of funny that the breeders are hitting cleanup. We've been setting the table for some whole lot of variety discussions all day long, so looking forward to that dialogue. And once again, thank you.
Right. Thanks, everyone.
Welcome back this afternoon to the Montana Agricultural Experiment Station, Montana State University Virtual Field Days. Thanks for the public for joining us on the YouTube Live. We have another section of individuals to answer your questions this afternoon from 2 to 3 o'clock. I want to take just a second before we start our interviews and thank Mike Suarez from Montana PBS, who really makes this process work. He's been behind the scenes all day long. He's been an editor of all the 56 or 60 some videos we have online for the educational purposes, and he's really put a lot of work and effort into making this happen for the Montana Ag Experiment Station. So thank you very much to Montana PBS and Mike Suarez. Other two people is Sharon Henderson. Sharon Henderson, the admin for the Department of Research Center. She's gone above and beyond making this happen. I get to be the pretty face in front of the camera, but she's done all the hard work making this happen and getting the videos wrangled and all that. And Reagan Collier, our communications director for the College of Ag. Between her and Mike, she makes the technology and all that work for all of us. So big shout out to those three and everybody that was involved with this and all the people that made the video. So it made it really well. So this afternoon we have, we kind of made this section entomology and breeding and variety developments for the individuals that are going to be introduced shortly. We've kind of set the table all day long. I don't know if that's a good thing or bad thing. The agronomists, the pathologists, and all the other people in the world kept throwing you guys under the bus to have all the answers and all the magic bullets. So with that, I'll go ahead and introduce everybody and give them a second and right after that to talk. We have Dr. David Weaver down in Bozeman, Dr. Mike Giroux, Dr. Jamie Sherman, Dr. Phil Bruckner, and Dr. Jason Cook. And so Jason, let's start with you and just give a brief update on what you do and who you are.
So I work down at MSU Bozeman, and I work closely with the wheat breeding teams. My primary role is to assist in integrating new economically important traits into the spring and winter wheat breeding programs. And then I also do quite a bit of research focused on studying genetic resistance for things like wheat stem sawfly, looking at drought tolerance and other disease resistance genes, and aluminum tolerance is another one we've been working on lately. So yeah, so my primary role is working with the wheat teams and supporting the wheat breeding efforts.
Thank you, Jason. Let's go up to David.
Hi, I'm David Weaver. I'm an entomologist. Been working here since 1997. Primary focus is wheat stem sawfly. That's what we work on. We also do work on some other insects. We work on trying to assess as many different strategies as possible for control of wheat stem sawfly. That includes interacting a lot with the breeders, spring, winter wheat, and also barley, since we have a little more sawfly and barley now. Looking at cropping system impacts on wheat stem sawfly, and answering a lot of questions about how come I all of a sudden have wheat stem sawfly this year when I haven't had them for quite a few years.
Perfect. Thank you, David. Mike.
My name is Mike Giroux, and I'm the Durham wheat breeder and also the department head of the Department of Plant Sciences here in Bozeman. So some of our major focuses is on creating Durham lines that have higher yield under dry land conditions in Montana. And we had our first release in January 2020.
Outstanding. Congratulations. Jamie.
I'm Jamie Sherman. I'm the barley breeder, and the barley program is working to improve both spring and winter barley for malt, food, forage, and feed production. Our newest release is Buzz, a low-protein daughter of Hocket, which we think will benefit both growers and end users. It's currently being tested by several maltsters and brewers, and certified seed should be available next year. Our next release in this coming year will hopefully be a forage line with improved biomass over forages that are currently being produced, barley forages that are being produced in Montana. But we've been able to increase biomass while maintaining grain yield, and we hope improving nutritional aspects as well. We're working on malt quality, disease resistance, and abiotic stress resistance, including drought, cold, especially in the winter program, and acid tolerance to acid soils.
Haver's not cold in the summer, so I'm glad you added that, Jamie. Thanks.
Well, sometimes you might get trouble with the spring early on.
I'm just teasing. Phil, let's go to you.
I am Phil Bruckner. I've been, I guess, living the dream for the last 28 years, and born in Montana and educated here at MSU Bozeman. And if I had any job that I could get, this would be the one that I would always wanted. And I've had a good time. Our latest releases, we have a comprehensive breeding program for winter wheat. And our latest releases are Bobcat, Flathead, and we licensed Stan Clair CLP to Nutrien this past year. So look forward to visiting with you.
Thanks everybody for joining us. Not surprising, the first question is going to go to Dr. Weaver. The triangle's been inundated with sawfly. Hard to keep up. What are the pros and cons of swathing wheat and sawfly levels?
So what are the pros and cons of swathing really quickly? Obviously growers swath for a reason, not just to spend the money, and that is to make sure that they windrow the wheat, and that way they don't lose much of the wheat that it would be otherwise lodged if you have a severe sawfly infestation. Disadvantages to swathing may be that it has a negative impact depending on how high your swath cut is on natural enemies, parasitoids that attack the wheat stem sawfly.
Do you have any rough economics on it, David, or a threshold or any kind of normal like threshold potentials that you could add to that dialogue?
In terms of how much you should have before you start swathing? Yeah, I think there was some older work that we did where we said that if you had over 25% cut on the outside, probably need to swath a few times around. If you have more than that, probably need to swath your entire field, like around 40% or so.
Perfect. Thank you. Thank you, David. With that topic, bringing on the sawfly topic, I think I'll just go to each one of the breeders here and maybe start off with Phil. And you have any comments on where your program is on sawfly development or sawfly prevention or resistance?
Well, I think really sawfly resistance and development of solid stem winter wheat cultivars has probably been our greatest contribution. And I have Jim Berg, that's kind of the right-hand part of the winter wheat breeding program. I guess that leaves me on the left side, but he works hard every year to document solidness at multiple locations over all our solid stem germplasm. So when we get lines into our sawfly yield trial, we're not worried about whether they have solid stem. We're looking at other traits like yield potential and also the direct effect of the sawfly on the cultivar, the cutting, how bad it's cut. And we have, tremendous variability even among the winter wheat lines with very high stem solidness just to document that phenotypically, and we base our selection on phenotypic stem solidness plus phenotypic resistance to wheat stem cutting. And then we're looking at other traits like quality and field performance. So that's why we've had an impact on sawfly and cultivar development.
Jason, anything in spring wheat you want to comment?
I mean, a lot of what Phil already said applies to spring wheat. What I would add is we've been doing quite a bit of research in collaboration with David's group, looking to identify new sawfly resistance genes and diverse germplasm found around the world. And we've had success in that. We've identified additional genes, pretty much all solid stem genes but they're in different locations in the wheat genome. So we're bringing those in to both the spring wheat breeding program and the winter wheat breeding program to add more diversity for to add potential for making even better solid stem wheat. And then also some of these genes might have some what we call linkage drag. So that means that when you pull these genes into your breeding program, they might also bring in some bad genes. So by adding a larger number of genes into our pool, hopefully we'll be able to cull some of those bad genes out and further improve the soft fly resistant wheats.
Perfect. Thank you. Mike, anything in Durham about soft fly you need to worry about?
Well, our initial crosses didn't have solid stem segregating. More recent ones have. So Durham has not traditionally been hampered as much by soft fly, but we hope it is in the future. In that, we hope more Durham is grown. So we are working on that. So a lot of our crosses have varieties like Fortitude in them, which is a Canadian variety that has solid stems. So our first goal is to identify lines that have high yield under the correct conditions, and then they'll be scored for solid stem. And so, of course, we will be attempting to create lines that have solid stem. We must have them now. They're just not at that stage of testing yet.
Perfect. Jamie, David did mention barley's being impacted more and more. How does this impact your program?
Yeah, so the interesting thing is that traditionally we think of barley as not being infested, even though it's hollow stemmed. And so we haven't really understood why that is. And the problem to look at it genetically is that we would need a barley that is impacted. And so now we've identified Hockett. He has a student that has done a survey of barley, and Hockett was one of the greatest impacted of the barley by the sawfly. And we've actually got a cross between it and a line that's resistant. And we hope we need to look for funding to fund it, but we hope that we'll be able to figure that out and identify whatever it is about barley that makes it resistant. And then that could be useful in the future.
Perfect. Thank you, Jamie. I'm going to toss the next question to Jason. Jason, probably I'm going to toss it to you simply because you talked about linkage and drag and some new modern techniques that you're investigating in. But a question earlier was to Kevin McPhee on how fast we can turn varieties. I mean, it was used to think it was 10 years between breeding and making it hit the streets, for lack of a better word. Can you talk about what you and maybe the other breeders are doing in layman's terms so the producers understand how fast or how you're able to turn varieties quicker this time of year than it was 10 years ago?
Yeah, so one technology Phil's using a lot in winter wheat is called a double haploid technology. And basically what it does is it allows you to skip the whole process of trying to get a variety to be, to breed pure, meaning that from one generation to the next, you basically have the same variety. It takes, 4 or 5 generations, well, at least 5 generations to get to that point. With the double haploid technology, I don't know, Phil, about year and a half, I guess, in winter wheat, somewhere in there, to get it to that pure breeding state.
Right. And then we figure it can save us 4 or 5 years we have a long breeding cycle, but we can save 4 or 5 years on priority material.
Yeah, so I think some people, maybe the quickest you can get a new variety out is 6 years versus, what would you say, Phil, 10, 11 years for you? Something like that for a conventional.
We're at least that long, yeah.
Yeah. And then there's another method out there called speed breeding. We haven't really implemented that one yet, but it's basically where you use a long photo period or long days, meaning the plants get around 22 hours of light a day and growing in certain conditions, and that can really increase the number of generations that you can get in a year. I'm not really sure, maybe 4 or 5 generations, whereas right now in spring wheat we can get 3 generations. So that's another method out there that people have been trying to increase the speed of the breeding pipeline. With that one, well, with both there's costs. So with speed breeding, you need to have dedicated people working on it because of the logistics of turning over this material pretty rapidly. So So yeah, there's a lot of labor that would be involved with that. And then of course with the double haploid process, it's, I don't know, it's like $40 a line or something like that to get one double haploid. And so it's pretty expensive too. So there's technologies out there that can really increase the speed of the breeding pipeline. It's just a cost to it too.
Okay, thank you. Next question is Mike. What does it mean when they're talking about durum quality, and what does it mean to end product?
Well, there's a couple key traits. Number one is color. So this is really important in durum. It's really important in spring and winter wheat too. But in durum, there's not much else in pasta besides durum. So if the color of the seed is wrong, of the semolina after milling the seed is wrong, the pasta is not going to be pretty. So color is number one. Number two is protein content and strength to make a firm pasta. And then starch type. So we've been working quite a bit on starch type. Selecting for lines that have increased amylose content, and we hope to have those out in a few years as well. Those will have a little bit lower glycemic index, which is great, you know, because you digest the sugars more slowly, your blood sugar doesn't rise as fast. But the other key thing is that they're just better. They make a firmer pasta that resists overcooking. So the main things though are color and protein content and strength.
Okay, thank you. Jamie, this is a one from Sheridan County. The producer asked, can you add one more end product line to start breeding for into your program, please?
What do they want?
I don't know, but just make it, I think they're making a comment that you're breeding for one of everything. So extensive program. But
well,
where are you?
You know, the way that works is it's a shotgun approach. And if you throw enough stuff against the wall, something's going to stick.
Got it.
So
Got
it's
it.
just to try to be successful.
No, I understand. But then the next talk is you talked about a new forage barley that was going to be released. Can you expand a little bit on that and talk about what that line is and where we're at?
Sure. We're right now making breeder seed. So next year it would go to foundation seed, and then the next year then being certified seed. Why do we want to do it? Well, there's some good varieties out there, but we think that just like that we can always improve. And what we were working towards is, for example, Lavina has really good grain yield and good biomass. But what we've crossed Lavina with a line called Cowboy, which is quite a bit taller. And so we've increased the biomass. It's also a little bit slower to develop, which actually helps with the digestibility we found. And so we're hoping that it'll be easier to digest for the animals, which will increase nutritional value. So that's what's on the table as far as the forage coming up, a cross between Lavina and Cowboy. And we haven't named it yet. We want to make sure that we really want to release it before we go down that road.
Perfect.
And the forage aspect, what's coming up in the pipeline, there's some really interesting material that has even more biomass. So we've crossed and even more digestible. So we're just going to continue to try to improve on those quality aspects of the forage line. And then with our winter program, the thing that we have coming up next is a winter forage. That's going to be the first winter that we release. And those are almost twice as tall. So we're hoping that they'll have a lot more biomass. And so we're kind of excited about those. We also think it's kind of like a low risk winter release. You know, if it got a lot of kill, and maybe the grower could still manage it. But anyway, that's sort of the idea.
Perfect. Thank you, Jamie. David, a topic came up and they came back in again just now during the discussion. They were talking about cover crops, pollinators, and pollen, and how that may impact as an integrated pest management strategy to help moderate sawfly. Could you comment a little bit about that and where you are in that project?
Yeah, so first and foremost, I guess since we've started switching to not necessarily planting all of our wheat one year and then fallow the next, and started to incorporate other crops, we wanted to look and see what would happen if sawflies emerged in those types of crops. So basically, if you plant peas on a field that was badly cut by weed stem sawfly the previous year, it has an impact on sawflies, but not as much as you'd think. The sawflies come out into the peas, they freak out, they don't live very long, so they spend some time flying around. If there happens to be a volunteer weed in there, there'll be like 100 eggs inside it. They eventually find their way out and they hit the surrounding fields. And it looks like maybe there's a modulation, 10% of the egg load or so isn't likely to get to the stems because they're spending that time and they don't live very long. As far as cover crops in general, one of the things that's really important is I mentioned parasitoids in the swathing question. The parasitoids are natural enemies that kill the sawflies. And one of the things is that sawflies are native. It's been here a long time. Parasitoids are native. And when they were interacting on the prairie before wheat was here, there was access to a variety of things on the prairie, including flowers that produce nectar. Now, parasitoids are little small things, so they can't use all plants the same way. So they can't take nectar from peas at all, because if they did, that would be great. But the nectar supplements the parasitoid's lifespan. It makes it so they can live longer, and that means they'll lay more eggs. They produce eggs, so they're not like sawflies. They're not short-lived. So certain things in cover crops might be very beneficial for parasitoids. Especially things that have what we call extrafloral nectar. So parasitoids have a lot of difficulty with certain types of blossoms, but a lot of species of plants produce nectar other places. Droplets of sugary nectar form, and parasitoids will drink them. And so we're focusing a lot on that to try and enhance parasitoids. I could say why that's so important is because ultimately the parasitoids and the solid stem together are what makes it so that a grower we'll see a decline in the sawfly numbers. Solid stems are the first avenue of defense, and then the parasitoids are very important. A lot of the places that are outbreaking now probably didn't have sawflies for a long time. The parasitoids need them to live on. They crash. Not all the sawflies are gone. Then the next thing that happens is they start doing better, and parasitoids have to catch up. So it's just a population dynamics issue. So all these things come together in sort of a big picture. Cropping is really important to try and manage sawfly, not just plant solid stem, of course, and certainly not just swath.
Great. So typical lynx hair type of relationship, even in sawfly and parasitoids. Yep. Outstanding. Mike, you mentioned earlier your department head, so I'm assuming this question is directed at you. Can you update it on new hires and where you are in the hiring process for critical positions in plant sciences?
Sure. Well, where we're at is at the university right now is it has a hiring freeze, so we're not able to proceed. Spring wheat program, Luther Talbert retired at the end of 2019. So that's a very important position for us. And we requested approval to hire a research scientist. So Phil is the current interim spring wheat breeder. So somebody to help Phil manage that program going forward. So Phil could talk about that separately. We have a couple other positions though too. One being the endowed chair position, also really important to us, but also frozen at this time. The lab is still available. We're still ready to proceed as soon as we get the green light from MSU to do so. We have an extension pathology position that also is frozen. And again, we'll proceed as soon as we get the green light to do so. That may not happen this fall. I don't know if Darren, you have better insight than I do in terms of the timing, but we expect it may not be this fall, right? It depends what happens with budget situation this fall, but we'll proceed as soon as we possibly can. And Phil could comment on spring wheat, and I guess we're looking to fill that position.
I would just add, we do have our advertising and position description. It's a good position for new PhDs, except it has a lack of permanence and security that because when we do want to hire our tenure track faculty breeder, this person may not have a job again. So, but we do have a good pool of candidates right now. I think maybe close to 30 now. And still another month to attract more candidates. We're looking for more good candidates, and we'll try to identify the best we can. This could be considered an audition for the permanent faculty position for some, and we're hoping that some will consider it in that light.
Perfect.
I would mention
The situation we're in is not unique either, so that's true nationwide, that positions have been frozen. So we're fortunate to continue, but as Phil pointed out, we will get a large number of applicants, probably because most positions like this are frozen nationwide. So Phil should have a large number of people on his committee, should have a large number of applicants to screen.
I would mention in terms of spring wheat breeding that we do have an excellent professional staff, Dr. Hua-Young Heo and long-term research associate Nancy Blake. Of course, Jason is assisting on that program, and all the steps are going to get done. We're going to advance germplasm, and but we need the artist to do the painting. We can do the brush strokes. We just need someone to lead that program, and we hope that'll come before too long.
Sure. Thank you. And just to supplement, it's not necessarily the university or Dr. Bajwa or anywhere up the chain. This is full border regions policy across all university policies. So this is something that with the pandemic that we're reacting to. And so it's not that there's lack of support for any one of these positions. It's there. They're just trying to make what's best decision right now with the pandemic. So, and Mike, I guess I'll rub my crystal ball. I don't know the answer. Jamie, to you, this question is probably a result of this morning's dialogue. We had a fairly robust discussion with Zach Miller about nutraceuticals and berries and nutraceuticals in other types of vegetable crops. You mentioned human consumption of barley. Is that kind of what you're working on in the barley industry, or what are you working for human consumption in barley?
Not pharmaceuticals.
Nutraceuticals.
Yeah. I guess I don't even know what that means, so I'm not working on it. But but what I think you mean is that they would have high nutritional value, like you could maybe isolate beta-glucan out of it or something like that and use it as a food additive. So we're focusing on the food. So people may not know that, barley normally has a hull, which makes it pretty impossible for humans to eat. And so a lot of the barley that you buy in the grocery store to put in your soup has been pearled, which means that the seed coat has been smoothed off of it. Just like an apple, the best part of the apple, the highest level of nutrition is in the outer layers. It's the same with the seed coat. The seed coat has a lot of good nutrition in it. So you're losing some of that nutritional value by pearling off the seed coat. So but we can also buy or create something called hullless or naked barley. And that barley does not have a hull. And so you could actually eat it, leaving the seed coat on. And so that would increase nutritional value, a lot of fiber in that. Barley itself is very high in nutrition. It has a lot of protein. It also has a special soluble fiber called beta-glucan, which is very good for colon and heart health, and that's just naturally occurring. And then we also, so the white barleys are high in nutrition, and some markets, for example, Japan is interested in some white barleys to use as a food additive with rice to increase the nutritional value of rice. And so we're hoping that eventually we can get into that market. Locally in Montana, there's been a tradition that organic growers have been interested in growing food barley that is purple, and it has a high anthocyanin content. That's what makes it purple. And anthocyanins are antioxidants, which are good for us. It's a vitamin, but it also prevents cancer. So the purple barleys are there as well. So when we started, there were a lot of issues, or there are a lot of issues, at least in Montana, with the naked barleys not yielding. And there's issues with poor germination. If you're too rough with the harvest of those naked limes, you can hurt the embryo. And so we're working on that. And so I think it's a pretty easy thing. We've already got some lines in the pipeline that are much higher yielding and stronger. And so we're hoping that our next line after the forage will be a food line. And that's kind of, the nice thing about having all these different things that we're breeding for is it does increase our ability to release lines for the growers of Montana. Every year we can come out with a line that doesn't compete with what we released last year because it can have a different end use. So I think that that's a kind of an advantage for our program, that we have that more flexible ability. So anyway, that's that for the food.
Perfect. Thanks, Jamie. I'm not sure who to toss this one because I think I know what this person's asking, but I'll let you guys decide who this is. This producer was from Great Falls, or this person was from Great Falls, and said they were at a field day a few years ago and saw plants that looked to be wheat, not growing in rows, but scattered out way away from each other. And I think they're referring to hill plots. And what are they used for, and what benefit do they get by planting crops this way?
I'll take a stab at it, because I think probably a lot of the hill plots that you see are ones that are planted for wheat stem sawfly research. As I mentioned, sawfly was on the landscape a long time ago. It probably utilized bunch grasses. Planting hill plots which basically is a small aliquot of seeds, like 10 seeds or so, in a spacing about 18 inches apart. Allows us to create that form. It allows for the sawflies to forage and explore the various cultivars, to move among them and make decisions about whether or not they're going to lay eggs, and also gives high exposure to the sawflies so that potential cutting is also very likely. So that may be what they saw. It's the actual spacing of those, and that's what we would put for crosses. Like, let's say we're working with Jason or Phil on a new line, and we have a cross, and we want to look at the progeny from that cross to see how the resistance manifests in that cross. We can actually look at all those different members of that population in the field, and through some statistical wizardry, get an assessment of how well that particular cross worked and how well that allele performs for resistance. And ultimately, one thing that we keep saying, solid stem, what it does is it kills small sawflies when they start feeding. So it actually is a tool for management from that point of view. If it's really solid, females won't like to lay eggs in it. They have to jab their ovipositor in the stem. And if it's really solid, they don't like it as much. When solid stem gets really cut bad, it's population dynamics again, Darren. It's basically how many eggs get put inside a stem. And if there's enough in there, they'll eat each other, and they'll survive the pith and cut the stem. It's an oversimplification, but kind of how it works. So you have someone stationed that might not have been supposed to cut, but probably did get cut. It might be because of a lot of eggs in the stem, and they're eating each other, not eating the pith.
Sure. Outstanding. Thank you, David. I assumed that's what the producer was asking, so good answer. Phil, your new variety Bobcat, what's winter hardiness, and where are you recommending that planted in Montana?
Well, Bobcat is not tremendously winter hardy, but it's winter hardy enough for north central Montana. We haven't seen big issues with it. We do test in Williston and Sydney with all our winter wheat advanced material each year, so we get a good assessment of potential cold hardiness, and it wouldn't be considered a very hardy winter wheat line, but we think it's great. It has a good yield performance since 2015. We're on our 5th year of yield testing in north central Montana, and we think it's adequate for most normal environments in north central Montana in terms of survival. And looking forward to seeing it in commercial production, getting it out into more environments, I guess. I guess the great thing in terms, besides its stem solidness is resistant to softfly cutting, is in north central Montana, particularly at Havre and Conrad, it has a lot higher yield potential than Warhorse, which is the current standard now for solid stem winter wheats.
Perfect. Thank you, Phil. Mike, this question was in, might be response to your comments about a new Durham variety. I don't know if you had the name of it, and where should that be grown, or where should producers be adapting that in their rotations?
Well, as part of the variety release process, new varieties or lines are tested throughout the state. So we tested at the Southern Station, Eastern Station, Northern Station, Western Triangle, and the Central Stations. So throughout Montana, with the exception of the Northwest part of the state. So Durham, though, is primarily adapted and grown in Northeast Montana and North Central Montana. So those are the two locations that'd be recommended. It's currently MTD 16005, but we're proposing the name Luster, which is a small town in northeastern Montana.
Outstanding. Mike, maybe for people that don't know, maybe a quick explanation of the difference between Durham and other stuff, other wheats.
Well, Durham is quite a bit different in that it perhaps hasn't been selected as long, and also that it's a tetraploid. And common wheat, spring wheat, and winter wheat are hexaploids. So Durham has 2 copies of each gene, typically, for many genes. Hexaploid wheat, spring and winter, has 3 copies. So the quality traits are a bit different for the two. Spring and winter wheat are selected for bread quality. Durham selected for pasta quality, so some differences there. Some traits found in Durham that we'd like to have that are not there are fusarium resistance. So one we're interested in adding to Durham is fusarium head blight resistance. So if you look at our new variety, it's not resistant to fusarium, and neither are any of the other current Durham varieties, but there is some resistance available in hexaploid wheat. So we're collaborating with somebody at North Dakota State University on lines he created by moving the resistance gene from hexaploid wheat into Durham, and we're making those crosses. So along those same lines, Jason also has funding to work on fusarium resistance. And our primary collaborator has been Frankie Crutcher. I know Jason is also collaborating with Ken Kephart of the Southern Station. So Frankie's at the Eastern Research Station. And when you mention hill plots, Frankie's also doing hill plots for fusarium resistance. So Frankie and Ken both have set up sprinkler stations so that we can do accurate selection for fusarium resistance among our new lines, both spring wheat, winter wheat, and Durham.
And barley.
And barley, sorry. I didn't look at those plots. I looked at all the other ones while I was there.
Good. This one in from Jordan. What comes first, breeding for yield or breeding for resistance?
To what? Resistance to what? I think it depends on what you're going for. So in the barley world, probably what comes first is especially malt barley having good quality. The producers and the end users will be okay if you have at least equal yield, but you got to have the quality. So that's why we instituted the Malt Quality Lab, because we felt like we needed to select earlier for quality and not just select on yield early. But I think it depends on where you are. Like the growers that are having trouble with wheat stem sawfly, they would like the first thing to be wheat stem sawfly resistant. So
I would mention that, there are options for fungicides to help control foliar diseases, and some producers have higher management levels and the ability and willingness to invest in fungicides, so they're willing to tolerate more, say yellow rust or stripe rust susceptibility to in terms to get a higher yielding variety. So traditionally we've always put disease and pest resistance very high in our list of priorities because our I guess report card is producers growing our varieties. We don't want just a select few growers growing our varieties. So ours are more broadly adapted to the pests that we have in Montana.
Anybody else want to take a whack at this open-ended question?
Well, despite the fact that I'd be a big advocate for resistance, I think that there is some ultimate agronomic truth. I grew up on a farm. You need yield too, for sure. You know, it's that trade-off. I think that's from my perspective, it's got to be a balance, right, between the two. You know, it doesn't do much good to have resistance that doesn't yield adequately. So it's something that's really been emphasized in the programs here for sawfly resistance, at least, is to try to boost yield as well as resistance. I think that's true. If Phil disagrees, he could say, but I think I'm right on that.
Yeah, I think. Oh,
go ahead, Jason.
I think yield and resistance definitely go hand in hand. One good example that we've worked with is there's a wheat streak mosaic virus resistance gene. It's been around for quite a while now, and we've been tested a lot, but unfortunately it causes a 10 to 15% yield reduction because it comes from a relative of wheat. And so it brings in a lot of deleterious genes that decreases yield. So Phil's worked a lot with it in winter wheat, and also Luther worked with it in spring wheat. And varieties were developed, but they were just never high enough yielding to warrant being put out for release because farmers just wouldn't grow them because the wheat streak wasn't present enough to warrant their use. So, but what we're doing now with wheat streak is there's some new genes that we're working with, and they don't seem to have that yield drag. So Phil's brought those into his winter wheat breeding program, and now we're bringing them into the spring wheat breeding program. So we're hoping to be able to get varieties that both have the yield and ability to resist wheat streak when it becomes a problem.
So I think I hear from all the answers that maybe the question is no one thing is more important than the other. You have to have yield, and that nobody really does single trait selection. It's multi-trait in our environment in Montana that you got to focus on a lot of different things when you're developing new varieties. Is that kind of what I'm hearing? Good. David, this one's you, and we got about 7 minutes. So I'm going to go really quickly to David for maybe a quick question and answer, and then I'll go around to everybody in the room just to kind of as a wrap up to finish up the day with. But David, we had quite a bit of a debate this morning about cover crops, and then we went into annual forages and impacts of annual forages with nitrates and a large reduction in oats. And I'm asking this because you and I've talked about oats and cover crops and what impact they may have, and maybe you could describe that why there's maybe an advantage to that in Montana, and maybe looking at that in some of our cover crops or other avenues.
Yeah. So real quick, oats is absolutely lethal to wheat stem sawflies. They use it just like wheat. They lay their eggs in it, but they die. I've not seen evidence of a cut oat stem, even under the most extreme experimental manipulations. It just doesn't happen. So it's a great tool for managing sawflies if you can put oat in that cover crop, and that cover crop is plopped down on a problem. If there's a fair amount of oat in there, that's gonna add to killing the sawflies. And that's a big advantage for sure. In fact, some people have said, growers have said that in the olden days when there was a lot more oats grown for horses, which predates me a little bit, but I think there probably was some impact of growing that specifically on the landscape, because it is an absolute dead end for the sawflies. They like it, they lay eggs in it, but they won't survive.
And you did some preliminary work on some of that in the cover crops and saw that they were being impacted. The oats were being implanted in.
Yeah, they definitely had a bunch of eggs in them for sure. In some of the ones on your station, for example, for sure.
Yep. Cool. Well, thanks everybody for being here today. I'm going to go around the room. We got about 5 minutes. Mike, you have any wrapping up comments or any thoughts you have?
Well, the biggest wrap up is that we enjoy working on Durham, trying to create new varieties and collaborating with the research centers in doing so. And one exciting thing that I didn't mention so far is that we have been having success at creating lines that are intermediate in height between semi-dwarf and full height that should have enhanced yield. And so those also should be coming in a few years.
Wonderful. Thanks, Mike. Jamie.
Well, I'd just like to thank the research centers for all of their good work and the data that they get to us. It's integral to our success. We need those data points to be able to release lines in a timely fashion. When you were talking about speed breeding, getting that data from around the state is integral to that. And then also the growers and the support from the checkoff dollars through the Montana Wheat and Barley Committee we can't survive without it. It makes all the programs go, and we just recognize that, and we would always welcome suggestions or comments. Our best ideas come from the growers of Montana, what we need to be working on. So I know we didn't get to talk to you directly, but please seek us out on our web page at Montana State, and then we're also on Facebook and Instagram. So please check us out, and we'd love to hear from you.
Thanks, Jamie. Jason.
Mute myself. Yeah, I just want to thank everyone for listening in, and thanks for our supporters, especially the checkoff dollars and from Montana Wheat and Barley Committee. And we're definitely listening. So if there's issues that are popping up out in our wheat growing regions, let us know. A few years ago, people started spotting an aluminum problem, and so we jumped on that, and we've been doing a lot of screening of our winter and spring wheat materials for aluminum tolerance, and we have lines that are tolerant to it. So we have germplasm and hopefully genetic tools to solve the problem. So just keep us posted on what's going on, and we'll try to help solve those problems.
Good point, Jason. And we talked about acidic soils, which is driving that aluminum toxicity this morning with Clayne Jones. So outstanding job on that. David.
Yeah, just same thing. Thanks for all the funding support. I also thank the growers that allow us to do research on their wheat stem softfly problems. We for sure have some ideas sometimes that we need to try, and you can't small scale it with the wheat stem sawfly. So I appreciate those people over the years that have helped us with that. And of course, that's been a partnership that has been fostered through the research centers as well. And I really appreciate that.
Thank you, David. Phil.
Yeah, I'd just like to kind of echo what everybody else has already said. Of course, there's a lot of people that help us out, and of course, checkoff funding, Wheat and Barley Committee, through the Wheat and Barley Committee, our collaborators on the research centers, and producers whose farms we're on. Some of them don't even like to see us coming because they know we're coming because there's a problem there, but that's what it takes to work through the problem, and we're working for you, the producers of Montana. So our objective is to develop kind of cultivars that you need on your operations, and not all the same. We're going to develop things that work better for some people than others, but that's part of the plan, that we want some diverse cultivar options. So thank you.
Yeah, thanks everybody. I want to thank our panelists today. And one thing I'll mention is, as department head of the research centers, I can't tell you how proud I am, and Mike could probably echo this as department head of plant sciences, is how proud I am of all the faculty interactions and collaborative work we have throughout the state of Montana. We can't do what we do at the research centers without the people in Bozeman. I think the feeling's the same way with the people in Bozeman at the research centers and that. And I kind of find it funny that in my 27-year career at Montana State University, we've been doing large, multidisciplinary collaborative work since we started. And now it seems to be the trend in most granting agencies and federal agencies that they're finally catching up to us on the frontier in that. And for the producers of Montana, that's really what it means to me, is that there's everybody pushing on the same side of the rock to make sure we're passing that research information to you so you can pass that farm and ranch on to the next generation and stay profitable. And so I know David's audio was in and out a little bit today. So if you have any questions for David, his email is listed as a contact source on our field day program, or you can Google him at montana.edu, as well as all the other people. So if you missed maybe some of his conversation and need a follow-up, please don't hesitate to address each and every one of you. Once again, I want to thank Montana PBS, Mike Suarez, Sharon Henderson, and Reagan Collier to make this happen. We did get a ping for our camp panelists all day long from Dr. Bajwa, the Vice President of Agriculture, complimenting and thanking everybody who took the time to make those 60 plus videos we have out there for educational opportunities for the producers and all the panelists that took time out of their day during harvest and during a critical time of the year to make this virtual field day happen. And I got to say, just personally, thanks so much for all your hard work and what you do for Montana producers. And so with that, we'll close our last section and thank our finalist panelists and wish them the best. Have a happy, safe harvest. Make sure weaning goes well. And hopefully we'll have a light winter and we'll recover from the 2020 brought to you by the Acme Foundation and the Wile E. Coyote Enterprises into 2021. So good luck. Thanks everybody for showing up today.